November NSC Math Paper 2 questions from the 2021 the 2021 final exam. So yeah, sure, I'm gonna have to say this up front. Like today, I don't wanna lie, my energy levels are very low, so I hope you are not find fault with me. So anyways, let's just dive into the paper. It says so. And I'm in a place where it's kind of a bit warm. Like those moments when you've like just bathed and then now it's like 10 degrees hotter. That's how I feel right now. But it says here, a bakery kept a record of the number of loaves of bread a tuck shop ordered daily over the past 18 days. Okay. Then it says the information is shown below. Okay, so 18 days. 1, 2, 3, 4, 5, 7, 8, 9, 9. What am I doing, bro? It's just 9 plus 9. So for 2 marks it says the following. Calculate the mean number of loaves of bread ordered daily. Well, this one is a straightforward question, right? You're just going to use your calculator, because remember, in your calculator you're going to say mode and then stat, and then you're going to put like var. It's going to give you like a table where you put in x values, which are going to be all these. And then once you're done, you're going to say shift and then stat, which will be the number 1 button. And then you're going to get options. Yeah, obviously from the options, you're eventually going to choose this as your mean. And then your mean is going to be 22. So obviously, I hope you will not find fault with me by not like wasting too much time on these questions, because these are the easy ones. This is where you like bank your marks. And then it says standard deviation of the data. So standard deviation of the data, you kind of follow the same process. Shift, stat, and then eventually you get your standard deviation. Let me see what this gives me in the calculator. Let's see here, calculator. 10.17. 10.17 into the calculator. Let me write it 10.7 so 10.17. Okay, for 2 marks it says number of days on which the number of loaves of bread was ordered more than the standard deviation. Number of days on which the number of loaves of bread ordered was more than 1 standard deviation above the mean. So being more than 1 standard deviation above the mean, this is what you need to be careful of. So this is the mean, right? What you're going to need to do is you're going to need to add your standard deviation once, and you get this number. Whatever this number is, you need to find out how many numbers are above that value, and then those will be the values that are over 1 standard deviation from the mean. So your mean here is going to be like 22, so it's like 22 here. And then your standard deviation here is like 10.17. So values that are more than 1 standard deviation from the mean, it will be values that values that are above the values that are more than 1 standard deviation above the mean. Let's see, it will be like 32.17. So any number that's above 32.17, let's see how many of those are. There's not a lot, but I mean, like, they're there. You have like 1, 2, 3, 4, 5. Oh, nice, it's in order already for us. Wow, man, such nice people. Like, oh my goodness, man, look at y'all being so, whatever you may call it. But I mean, like, this kind of equation, we do kind of need to, like, we do kind of need to, like, just double check the question. It says number of days on which the number of loaves of bread ordered was more than 1 standard deviation above the mean. More than 1 standard deviation above the mean. Yeah, you're gonna have 5 days, you see. 5 days. You see, it's 5 days in total where your standard deviation was above the mean. So anyways, let's check the next question here. The tuck shop owner was not able to sell all the loaves of bread delivered daily. He calculated the mean number of loaves sold over the 18 days to be 20. Okay. Calculate the number of loaves of bread which were not sold over the 18 days. Okay, this is quite a dumb question. Okay, fine, it's not that dumb. It's just like weird. The shop owner was not able to sell the loaves of bread delivered daily. He calculated the mean number of loaves over the 18 days to be 20. Okay, so on average, he sold 20 a day. Calculate the number of loaves of bread which were not sold. Well, if the mean is 20, then it means over 18 days, he sold, I'm struggling to do 20 times 18. Yeah, I'm thinking 360, but ish. Calculator, let the calculator do that for us. 20 times 18. So he actually sold 360. So let's see here. 360 sold. Here they said how many of them were not sold. So we have to say the ones that he bought. You see, obviously everything that he ordered. So let's say we have a mini formula here. Whatever was ordered minus whatever is sold will give us whatever is left over, you see. Or whatever is not sold. I'm like, hello there. So let's see here. Not sold. So for us to work out how many things, how many loaves is sold, you actually just have to add this, of which your calculator can get you that value, you see. Your calculator can easily get you that value. Let me just show you how you can get that value quickly. Let me just grab the calculator here. So in your calculator, right, for you to get this value, this is what you're gonna press. You're gonna press mode stat and then sum. Okay, so in this one here, shift stat, here you were eventually gonna press var, and then you choose this. It's the same here, eventually you're going to press var and then you choose that. But for this question here, right, it's quite easy, right, because you want to work out how many was ordered. So to work out how many was ordered, you're going to press shift and then stat and then just the sum, you see. So let us see what the calculator is going to give us here. Let us be, let's see. Just wait. I like it. Just wait. Yo, I feel like just, yeah, let me actually just pause here quickly. I come back. Anyway, so in your calculator, you're gonna press shift mode stat and then sum, and then you're gonna choose this option. You see, it's gonna give you 396. So obviously here you're gonna get 396 minus 360. You're gonna give it. It's gonna give you a difference of like 36. So 36 is your final answer. The ones that were not sold is 36 because you bought 396, you sold 360. The rest is what's left. Anyways, let's see here. So the other way you could have gotten this 36 is to have used the average of everything that was ordered, because everything that was ordered, the average of that was like 22. So 22 times 18 would have also given you the 396. Anyway, so let's see here. 1.6 says one of the box and whisker diagrams drawn below represent the given data in the table. One of them, but we have two diagrams here. Two diagrams, and are we supposed to like choose which one of the two box and whisker diagrams drawn above correctly represents the data? Write your reason for your answer. Yo, goodness. Well, obviously, let's check the maximum here. The maximum is like 41. They both have the same maximum. They both have the same minimum. Very slick. Very, very slick, people. We see you. So we obviously have to compare Q1, Q10, Q3. Well, the easiest way to compare is, let's look at the median, Remember, the median is the one that's in the middle after you sort out your data from smallest to biggest. This is already sorted nicely. So you see here, this is 1 to 9. And then from 10 to 18. So obviously the median is going to be between 18 plus 19 divided by 2, man, Median is going to be like 18.5. So median here, you see it's like 18.5. So it's going to be graph 2, and you choose base. You can literally just say that. Let's say here graph B, because the median, let's see here, median is, what is the median, is 18.5. That's the way I like it. Describe the skewness of the data. So in terms of you describing the skewness of the data, yeah, I mean, like, there are tutorials on this on the channel, so you don't need to, like, worry about it too much. You literally just look at the side that has like the longish tail thing going on, you see, of which it's this side, the right side. So here you can say skewed to the right, skewed to the right. Yo, man, this pen is like jumping, eh? He's jumping. What do you want to do, huh? Do I jump? Go to the Olympics. Yes, like, what am I saying? Calm down. Let's stay organized. We're doing well. Anyways, question 2 here says, a farm stall sells milk in 5-liter containers. Yo, okay. That's a lot, eh? To the local community. And then it says here, the price varies according to the availability of milk at the farm. Price of milk per hands. Okay, and then it says here, number of 5-liter containers of milk sold. So okay, fine. So they said here the price varies according to the availability of milk. So the assumption could easily be the less milk the less milk there is, the more expensive it's going to be. The more milk there is, the cheaper it's going to be. I mean, like, just pure economics, just basic supply and demand. I mean, like, this is just pure logic. When something is in a high demand, it's going to be expensive. But when it is just like everywhere, it's cheap. Says here, the price varies according to the availability of milk at the farm stall. The price of milk in rands per 5-liter container and the number of 5-liter containers of milk sold are recorded in the table below. Then it says your price of milk in rands per liter. So these are the different prices, right? So like 26 rands, this is how much. Okay, number of sold. Okay, so obviously, I mean, like, the cheaper it is, the more you're going to sell as well. Like, yeah, it's cheap here, sold this much. It's a bit expensive, sold less. And let's see, you see here it's quite high, and it's definitely sold less. So that's the trend we can see here. The more expensive the milk was, the less they sold. The cheaper the milk was, the more they sold. Okay. 3 says, on the grid provided in the answer book, draws a scatter plot to represent the data. Yeah, we cannot do that. I'm like, hello, So it says here, let's see, price of milk in rands. It's like 26, and so you're just gonna plot nicely here. Let's see. Price of milk in rands. Yes, it's like 26 and 48. Yeah, you see, plotting this is at least better, It's like already done for us. 26, 48 is gonna be like somewhere there, man. And then what you say here, 32 and 30. Price of milk in rands, 32 and 30. Yeah, 31, 32 and 30. So it's like over there. 36 and 26. Price of milk, 36 and 26. Price of milk, 36 and 26. 36 here, 26 is gonna be like somewhere there. Yo, this is gonna take long, eh? Okay, it's not. 28 and 44. Where is 28? 28 and where is 44? 44 is gonna be like somewhere over there. And then 40 and 23. 40 and 23. It's gonna be like somewhere there. 33 and 32. So it's gonna be like 31, 32 and 33. It's like somewhere there. And then it's like 29 and 39. So let's see here. 29 and 39. 39 is like somewhere there. Then he says here 34 and 29. Price of milk, 34 and 29. 34 and 29. 34 and 29. Like, it's funny how I'm doing this right now, but I promise you my brain is like somewhere else. 27 and 42. Let's see here. 27, 42. Where are you? 42 over there. Last but not least, 30 and 33. 30 and 33. Let's see, 30 here, 33. Where you at? Where you at? Over there. Nice, nice. That is the way we like it. So you're gonna get your 3 marks over here. Nothing crazy, nothing major. I'm like, hello, you know what I'm saying? And then it says the following. Let's see what it says here. It then says here for 3 marks, right? What does it say here for 3 marks now? 3 marks here says just determine the equation of the least squares regression line of the data. So remember, your least squares regression line looks like this: a plus bx. You see, nothing crazy, nothing too major. But in your calculator, you're gonna need to put in all this data. So yeah, we have to clear your calculator first. You see, by saying shift and then 9. So in your calculator, you're gonna say mode after you've cleared it. You know, you say mode. Then stat, they're gonna choose a plus b. Then you're gonna choose, or you're gonna have two columns pop up, and then these 2 columns, ne? Gonna put here this, 1, 2, 3, 4, 5, 6, like that. And then what? And then you're gonna have the how's that thing? Hi, man. What you doing? You're gonna put in your date. You're gonna press on, right? And then you're gonna press the following. You're gonna press the shift, and then you're gonna press the stat, like the 1 button, and then you're gonna choose the a plus b, and then you choose a and b. You know. So when you choose A, let's see what you get on the calculator after putting all this. So in the calculator, we are getting the following. Our final equation is going to be y. A value is like negative 1.774. And then B, after doing the same process, why are you doing this, man? Why you got to do that? It's gonna give you 90.478. 2 marks says, if the farmer sells a 5-liter container of milk for 38 rand, okay, selling it for 38 rand, predict the number of 5-liter containers that he will sell. So price is 38, meaning that's on the x, right? You see, so x is gonna put 38. Let me not forget to put x over here. So here you're gonna have y is equal to negative 1.774. Price is like 38. 90.478. Okay, let's put everything in the calculator. Negative 1.774 is like 38 over here, plus 90.478. Hey, 38. It's gonna give you 23.066. 23.066. Yeah. So that's like 23.06 actually. Whoo, 23.07 actually, because it's like 66. Anyways, question 2 marks usually says predict the correlation between the refer to the correlation. Okay, so we need to refer to the correlation. Okay, that's quite interesting. We need to refer to the correlation. These people is telling us to refer to the correlation. Refer to the correlation between the price of the 5-liter container of milk and the number of 5-liter containers sold, and comment on the accuracy of your answer. I mean, like, commenting on the correlation of the two, it's exactly what we said in the beginning. You see, just say it bluntly like that. The higher the price of the milk, the less 5-liter containers sold. You see, the higher the price. Let me see here. the higher the my handwriting is nice, eh? Yeah, Nobel Peace Prize just for this. The higher the cost of the milk, the less 5-liter containers sold. And then compared to what we have done here, what you can do for yourself is, with this data, what you want to do is just look for where this would fall in 38 and 23. So 38 price is like somewhere there, and then 23, so it's like 38, 23 would be like somewhere over there. So yeah, that kind of follows the trend, you see. So you can basically state that, you see. So the prediction is accurate because the data falls close to our other points on this scatter plot, on the scatter plot. So anyways, while I'm typing this out and I see this, I'm gonna plug myself real quick. Anyway, so this is actually quite important, actually, depending on when you're watching this, because if you're watching this like now in 2021, and it's like in November right now all the way to December, then you want to remember that if you're in grade 11, it would be or if you know someone in grade 11, then it would be a very good idea for you to plug them with the courses, because right now the courses are like, the whole access pass is like $99, but then original price is like $7.99 per month. You see, like so far the subscription is like 100 and it's like just 99 rand a month. So if a person subscribes now, it means that's like going to be their subscription over the year next year, if they're in grade 11 now, obviously. But then if they wait until January or whatever, then they would be paying like the $7.99 per month, for like the courses and stuff. So what I'm trying to say is, if a person is in grade 11 now, or you're going to upgrade or whatever, it will make better sense for you to like sign up right now, because it's still low. But anyways, let me carry on with the paper. Question number 3. Question number 3. Finally something exciting. I don't know. I think if you've gone through some of the online courses, when I started with the stats course, I was like, you know what, I don't like statistics, and I really don't. It's such a boring topic. It's like so easy. It's not like I hate the marks. It's just like it's so boring, man. Like where's the entertainment? I know I sound so dumb right now. I'm like, this guy, entertainment. What you talking about? It says here in the diagram, A, you have A over here. It's -2 and 10. B is K, coordinate K. So the X value and the Y value of B are the same. C is like -4, is like 4 coordinate -2. So as you're reading, right, you obviously need to be like, just taking note of what they're saying here. These are vertices of the triangle ABC, and then it says line BC is produced to H. And then it says it cuts the x-axis at E. And then it says here AB, where's AB? AB and BC intersect the x-axis at F and G respectively. Very nice. The angle of inclination of AB is like 81.87. Okay. Calculate the gradient of BE. Where is BE? Gradient. How? Can just use the gradient formula. How? Come on now. Yo. Let's see. -2 minus 0. -2 minus 0. And then 4 minus 12. 4 minus 12. So obviously the formula, if you want, I'm like, why not? It's free. Might as well use it. Formula. Y2 minus Y1. X2 minus X1. That's what we're using here. So what you gonna get is gonna be -2 over what you get here. It's like -8. Right? Is this a positive grade? Like, yeah, it's positive grade. This is more like is it a quarter? Is a quarter, my bro? Is a quarter, because the negative comes with the negative. Okay, the gradient is a quarter. they want us to get the, wait, what is this now? Gradient of AB. I think they just, yeah, I think these two kind of, you know, have the same question. They want us to get the gradient of AB. We can clearly use the angle of inclination there, like, hello, you know what I'm saying? Okay, I'm not trying to be condescending or anything, né? I'm sorry, don't feel offended, okay? Don't feel offended. So because the angle with the x-axis will always get you your gradient of this line here. And the angle of the x-axis has to be coming from the left. You see where this is like, I mean, coming from the right, where this is 0. And then up here is like 90. And then, you know, so it's like 0 here. This is just before 90. In the calculator, let's see here, 81.87. Put that in the calculator. Calculator, please help us. I was about to say, please do your job. But I started the main thing to say, you know, it's like, it knows it has a job to do, man. You know, now that I'm doing this question, I'm just drawn back to this thing here. Refer to the correlation between the whatever. Let's see here. I think for this question, it would have been a good idea to also mention what the correlation coefficient is, you know. So let's do that. The correlation coefficient here, before I forget, let's just check it in the calculator. It was R is equal to negative 0.94. And then you can carry on with whatever it is that you would have said. But if you left it out, let's see, refer to the correlation between, honestly speaking, leaving it out, in this case, it's really not a big issue. But hey, it just came to mind, that thought. Oh, sidetracked a bit there. Back here. Let's see, if you put all this in the calculator, what you gonna get? It's gonna give you a 7. It's a weird gradient, right? Like, who gets a gradient of 7? Like, such a weird number. It's like, what? 7? One is getting a quarter, the other one 7. Just like that. You're off ramping, my guy. You're off ramping. 7. Aye, man. But let's see. 2 marks here. They said get the equation of BE in this format. Where is BE? How? We already have your gradient, most. I'm not gonna hate, but this is nice. Very nice marks here. And I mean, I recently actually started using this formula. I actually never used to use it. But, you know, sometimes, you know, you get to see something and they're like, it works. And it's 4 and negative 2 is what I'll use, because why not, right? 4, no, what you doing? Why are you messing up such a good tech team, eh? We're working hard here. 4 and negative 2, so let's put the gradient, we worked it out to be a quarter. Y value was negative 2, so here you have to put a plus 2. Double check nicely, everything is all good. Yes, let us simplify. Y here, this is gonna be like a quarter x, and then this is like what you got, negative 1, and then this is like negative 2, so this like y is got like a quarter x, and then negative 3. Interesting equi, but it is what it is, man. Correct answer, because I'm like, how can you get that wrong? Moving on. Let's see what you got. It says, what you get here. Coordinates of B, where k is smaller than 0. Like, duh. I'm sorry, but it's like, of course it's smaller than B. Look at where it is. It's on the negative side here. It's on the negative side. You know, sometimes these questions, they just say the dumbest things. It's like, duh, of course we can see it. But hey, let me not hate, because obviously, who knows? Maybe we're going to get to answers, and then obviously this is the way you'll see that you have to choose the positive one. So we can easily just work out where AB and BE meet, you know, so clearly we can just get the equation of AB first, because, I mean, it looks like that's the easiest thing to do. So y minus y1 is equal to m, and then x minus x1. This is for AB specifically. So let's see, coordinates of, we need a coordinate that passes through this line. It's like negative 2 and 10, right? So it's like, negative 2 and 10. Yeah, x value is let's see here, y minus 10. Gradient, what's your gradient now? Gradient is like 7. X value here is like negative 2, right? So it's like negative 2 over there. Negative 2 here. No, bro, come on. This one stays x, okay? This one becomes the x value. Whew, is good. Is good. So let's see. Y here is 7x and then plus 14. The 10 goes over, that's like a 10. You have like 7x here plus 24. We are love to or see it, man. Hey, moving on. Size of A. What is the size of A now? Where is A? I know, we're not done. Why are you moving on so fast? I only got the equation of AB. I need to equate AB with the other equation there. So let me make some space. You see, I have a tendency of doing things like this. You just write the question, you get an answer, you're like, is it done? No, we haven't even answered the question yet, my guy. So we're gonna take this side here, equate it to that there. So let's see here. The y of AB, the equation of AB is equal to the equation of BE. So you're gonna get here like a quarter. How? What is the y value of AB now? 7x plus 24, and then here by is like a quarter x minus 3. Let's move everything to one side. It's like 7x minus a quarter x, negative 3 minus 24. This is like negative 27. What is 7 minus a quarter? That's a difficult one, man. I gotta use the calculator for this one. Because, imagine someone knowing 7 minus a quarter from their head. It's like, hey, what? Joe? It's like, Joe? What? How, Joe? Like, how? Hey, imagine 7 minus a quarter. Hey, but it's actually not that much of an issue. It's just like kind of funny, It's like 27 over 4 here. So 27 over 4 is the answer. Let's see, 27 over 4x. And then you're going to divide by 27 over 4 on both sides. So x is equal to negative 27. And then here you have 27 over 4. Hey, bro. Chill, man, chill. So x here is going to be a negative 4. I'm like, which is good. Therefore, that's the x value where they meet. So if the x value that they meet is like negative 4, it means the y value is also negative 4 because k is just the same for the x and the y values are the same, That's like negative 4. Nothing to worry about here. You would have just been able to put this in the calculator. It would have given you the answer. Anyways, the question was asking for the coordinates of B. So be sure to make sure that the answer shows what you are get here. Let us carry on. Size of A. Must be interesting. So you see when you're getting the size of A here, don't focus too much on A, Like legit, you're just wasting your time. The reason why I say you're just wasting your time is because I'm like, hello, you need to do this. You need to do this. What? Oh, wait. You need to get this angle. And you can easily get that angle, can you? How? Now I have to get the equation of AC or the gradient of AC-ish. The one thing I can say is, don't be lazy, It's just like this analytical geometry section is just so boring as well. It's like, you're boring, you. Why? Ish, I'm sorry. I know I sound kind of weird. Like, this guy is saying it's boring. But it's 3 marks. So I'm going to get this pink angle by getting the gradient of AC first. So let's get the gradient of AC first. So let's do it. The gradient of AC, y2 minus y1. Let's see. Let's say here 10 minus the negative 2 over there. So it's going to be 10 minus the negative 2 over there. Now let's see. 10 minus the negative 2. And then what else you're going to get? Negative 2 minus 4. Negative 2 minus 4. Negative 2 minus 4. And then what? This is like a 12. Negative 6. This is like a negative 2. That's the way. I like it. So the gradient is like a negative 2. So use that to get the pink thing over there. So shift 10 is equal to m. We're gonna put here 10. 10 theta is equal to negative the 2. what you gonna get when they come for you. Tan theta is equal to m. So it's gonna be tan theta is equal to -2. So let's see what that gives us in the calculator. Calculator on the left hand. Please give us the answer. Let's see here. Wait, do we do 10? Yeah, 10. Wait, shift 10, bro. Come on. Yo, focus, my guy. Focus. Yeah, see, man. You're not focused, man. But to be honest, now, when you're going to get this angle, the one thing I always try to specify that I am going to need to showcase right over here, because it is like, very important and stuff like that. What you're going to get here now, you need to be careful. You need to be very careful, because this is just going to give you a reference angle. Or when I say a reference angle, it's just going to give you something to use to eventually get your answer. So don't just always jump to taking this as your answer, because this answer here is giving you -63 point what's this calculator giving? 0.43. Don't just take that as your answer. This is just giving you an idea of what you can do to eventually get your final answer. So all that means is this side here, you're obviously going to take it as a positive number, right? It's just 63 63.43. This pink side here, you would have gotten it by saying 180 minus the 63.43. So don't stress too much. That 63 point something, it's just this acute angle over here, you see. So you have this 63 point something, you have this 81 point something, so you can easily get the angle A over there using interior angles of a triangle. So let's see here. So you're going to have angle A here. Angle A is equal to 180 degrees minus 63.43 minus 81. Is it 81? 80 what? 81.87. Let's see here. 81.87. And then what you're gonna get when they come for you. Let's see, 180 minus 63.43 and then minus 81.87. Oh, what you getting now? You're getting there 34.7. 34.7 is what you're getting. So let's put here 34.7. Fantastic, man. Fantastic. Anyways, moving on here for 2 marks. It says coordinates of the point of intersection of the diagonals of parallelogram ACES, where S is a point in the first quadrant. Whoa, gotta read this again. Oh, we need to get the point of intersection of the diagonals of the parallelogram if ACES is a parallelogram. Let's see what ACES is. Let's check it out here. There's A here, there is C here, there is E here. So S would be somewhere over here or somewhere down here, because they said it could be in the fourth. They said S is in the fourth quadrant. Let's check this out. S is in the first quadrant. Oops. So S is like definitely somewhere there. So meaning this, you're gonna join it. This, you're gonna join it. Say no. What you got here? What you doing? This, you're gonna join it. Yo, this would be the parallelogram. It looks like a very weird looking parallelogram. This one, ish. Ha, man, my parallelogram drawing skills. They are not they are not very good. They are not very good at all. But hey, let us try. Just do that. And I'm not. You get the idea, man. You get the idea, ish. But no, man, why am I giving up so early now? So easily, even. Anyways, this is where S would be. They're saying we should get the. Did they say the coordinate of S? Let's just check it out here. the coordinates of the point of intersection of the diagonals of the parallelogram. Okay, so S is the point of intersection of these diagonals here, as in this one here, you know, where this one meets this one over there. So yeah, we need to do that. So let us just do it. Anyways, to get this point here, you're gonna use something quite simple. Wait, how many marks is this question? Oh, 2 marks. Okay, yeah. So you're gonna use something definitely quite simple, because you're just gonna compare how E and S are. You know how E and C are. The difference between E and E, you're gonna use that to get A and S, because you see here from 4 to 12, that's like a jump of like 8. So from -2, you have to jump 8 as well. That's gonna give you a +6 over there. Let me repeat. From 4 to 12, you have to jump 8 units. So from -2, you have to also jump 8 units. You're gonna get a -6. I mean a +6. From -2 to 0, you go up twice. So from 10 here, if you go up twice, you're gonna get a 12 over there. So that's why this is just a 6-mark question. I was about to overthink it so hard, but this brain, I don't wanna lie. Nah, I'm going through this paper now, but I want you to know my brain is tired. But hey, gotta do what you gotta do, man. Gotta do what you gotta do, even when you don't feel like it sometimes, you know, like just walk through the pain. I'm not in pain, like physically or anything, but hey, who knows? Who knows emotionally what's going on here? Another point T. Let me just pause this for now and then carry on. Another point T. Another funny like things like this, where P is a positive number, is plotted such that ET is equal to BE and it's equal to this value. Calculate the coordinates of T for 5 marks. Okay, I think this one is the one where the overthinking is necessary. Let's see. They say T is this coordinate where T is a positive number. Here, I think it's kind of valid for them to tell us that T is a positive number, because, I mean, P, bro. You keep saying T, my guy. It's P. Huh? Boy, you don't know what P is anymore. Shame, man. It's mathematics. Look what it's doing. So they said ET is equal to BE. Where is BE? In the first place. So ish. BE, where are you, man? There is BE over here. And then they spoke of ET. So E starts over here. They say T is in the positive quadrant. I mean, they say T is P coordinate P. So if this is E here, right? T, let me just shrink this. You see so much writing here. This is why I'm just delete this equation. Like, everyone knows what the equation of gradient is. It's on the formula sheet as well, Anyways, all this being said, T is going to be like, like one way or the other, like, T is going to be like, I don't know, like, somewhere over here, maybe, like, I excuse me. I don't even know why I'm getting sidetracked. So T is somewhere there. So, this is not going to be to scale, but they told us that TE is equal to BE, and they're both equal to what's that number of a day say? 4 square root of 17. Nah, for 5 marks now. Ish. Gotta do what you gotta do. So what you gonna do to get this length? Ish. Yeah, me I don't align it, but it's beatingness a bit. So let's see. We have this here. I'm thinking of like the distance formula, but yeah, then what? Because you can get the distance here. I mean, you already know the distance here. It's like they said it is 4 square root of 17. The distance there is also 4 square root of 17. The good news here is that T is a point where P and... Oh, yeah, we can use the distance formula because like P and P are the same. That's the X and the Y value. Like, dumb questions. Excuse me. I don't mean that in a mean way. I just mean like, it's put square root here. Let me just write the coordinates of t here so that we can see them. P and P. Let's write the coordinates of E. Where is E? E is like 12 and 0. So E is 12 and 0. E is 12 and 0. Let's see here. Let's see. 12 and 0. So it's like P minus 12, right? P minus 12 squared. And then here, P minus 0. P minus 0 squared. And then, let's see TE. What is TE? They said it is 4 square root of 17. 4 square root of 17, right? So it's like square root of P minus 12 squared plus, this is P minus 0, so it's like P squared over here. Okay. So you're going to square both sides, right? So let's just square both sides. If you square both sides here, you see you can square here, square here. This is going to give you 16 times 17, you know, because the square, 4 squared is 16, square root of 17 squared is going to be this here. And then here, the square root symbol is going to just get, you know, cancelled. Cancelled culture. That thing is scary. Let's see here, 16 times 17. Hey, Mr. Calculator or auntie calculator, because aunties are smart. You know, aunties, they just know everything. 16 times 17 is like 272. 272, eh? Let's see here, 272. Oh man, P minus 12. The whole thing here, P minus 12 also. And then here, P times P. This is like P squared minus 12 plus 144 and P squared 272. So let's take the P squareds together. Take everything to one side. You're going to have 2P squared minus 24P. And then plus 144 minus 272. Let's just see what this is here. Let's see. This is going to be like 0, right? 2P squared minus 24P. So 144 minus 272. Let's see what 144 minus 272 is in the calculator. It's going to give us like negative 128. Okay, very nice. Hey, Mina, you know me. Or maybe you don't, but hey, I'm going to use the quadratic formula right now. So let us do it. P is equal to minus B plus minus B squared minus 4AC over 2A, right? And then here, you have here P is equal to minus B. So it's like minus B plus minus, then it's like B squared minus 4AC. And then you're going to have 2 times the value of A here. Put all this on the calculator. See what our answer's getting. We are getting a 16 and negative 4. Okay, so you have to pick one that's a positive, obviously. So P is equal to 16 over here, or P is equal to negative 4. You're going to cancel this one. So yeah, P is equal to negative, P is equal to positive 16 over here. So our value of T is going to be 16, coordinates 16, you know. Very nice. Nothing crazy too much here. 3.4.2 says determine the equation of the circle with center E and passing through B and T in the form this. Well, this kind of equation is actually not difficult. The reason why it's not is because, you see, the moment they give you the coordinate of T here, you have to remember that this is a 90-degree angle. Like this specific... Okay, wait, let me just go back to the question. I'm busy jumping the gun here. what they say here. We should get the equation of a circle passing through E, B, and T. You see, I'm being jajarach. Where is E? E, B, and T. Yawa, pop. What does this have to do with anything? Ish. Let me cut this out. So this is B, E, T. There's a circle that passes through those points. Ish. But it's a 2-mark question. Let me just read it nicely, Center, they say determine the equation of the circle with center at center E. Oh, at center E. Oh, thank goodness. Okay, let's just make use of that. The center is E. Okay. Oh, I mean, like if it goes from E to T, and it goes, wait, whoa, man. If this is the center, so we can get A and B from here, and then, I mean, like, the radius obviously has to be 4 square root of 17, because if this is the center and this is a point on the circle, I mean, like, from the center to any point on the circle, that's the radius, you see. From the center to any point on the circle, that's the radius. So radius is 4 square root of 17 and the center is E. So that's pretty simple, I guess. Okay, it's not pretty simple, it's just like, some good vibes. So let's see. E is like 12 and 0, so we have to use the opposite of those. So it's gonna be like negative 12. Y here, it can be like a 0, and then your value of R is 4 square root of 17, remember, but we squared everything, so this is what you get. Fantastic. They said here you should get the equation of the tangent to the circle at point B. Remember, B is like -4 and -4, and remember, getting the equation of a tangent to a circle, it's quite simple. I mean, there are tutorials on that on the main channel, #BrightChungBrains. So if this is if you have a tangent to the circle, let me just try and draw the image for you so that your life can be a bit easier, yeah? So you have E here, né? And you have T. No, bro. There's E down here. There's T up there. And then there is what? There is B here. You see? And then you have a circle around these points. You have a circle here, so here's a circle. Ooh, it's a nice looking circle. Look at that circle. Okay, that's just weird, bro. Like, dude, what the hell, bro? I'm pretty sure I can draw a better circle, but I know, man. No, don't embarrass yourself like this. Finesse this circle, man. Finesse it real good. Boop. Hutch, I told you I can finesse this circle game. Just finesse it. Why you got to do funny business when there's technology here? Hey, technology is here to help us, and we're busy here doing freehand. Hey, people just want to work hard for nothing. So this is like T up here, né? There is E here, and there's B over there. They said we should get a tangent to the circle, so the tangent would be like there, but like, ooh, did you see how it went to the circle? You should like rewind and see how I just drew, and then it went straight. I'm like, how did you know? How did you know that I wanted you to go there? But anyways, with all this being done, what is E? What is E again? It's like 12 and 0, ne? What is B? B is like -4 and -4. So if you're gonna get a tangent to this circle, ne, it's quite easy, because I mean, like, if you've gone through the tutorials on the main channel, then I mean, like, this is easy for you. The equation of a tangent is just a straight line. You see, y is equal to mx plus c, and then you have to make use of the Euclidean law that says that this angle is a 90-degree angle. So the first thing is you need the gradient of BE. Actually, let's get the gradient of BE. 0 minus 4 over there, and then 12 minus the 4 over there. You're gonna get here 4 over 16. You're gonna get like a quarter. Very nice. So we had that gradient already. Okay, but anyways, so that's BE. Obviously, to get the gradient of the tangent, you're gonna have to say the gradient of BE times the gradient of the tangent. Let's just say gradient 2 there. This is going to be equal to -1, of which if you throw in that information here, you're going to get like a quarter times m2 equal to -1. Divided by a quarter on both sides, you're going to get here m2 is equal to a 4, a -4 actually. So that's the gradient of this line. You see? Once you have the gradient of that line, you can obviously just put it into this formula. Y minus y1 m and then x minus x1. What is the, let's see here, y minus y1, right? And then gradient here is like -4 and then like +4. Okay, then it's like y here, everything on one side, it's going to be -4x, -16, -4. This is like y minus 4x, -20. Okay, it's good, eh? It's good. That is it. That is literally all you'll have to do for this kind of a question. So this question paper, yeah, was genuinely fair. So far so good. I'm like, you know, just 3 marks everywhere. I just hope that we can deal with a different sketch now, because now I'm tired of this one, man. I'm tired, man. Good questions there. Let's move on. In the diagram below, no, in the diagram, there's no below here. Where are you reading below? Me. Busy lying here. Anyway, so in this diagram, what did they say? In the diagram, the circle centered at N. This is a -1, by the way, for those that don't know. This is a -1, coordinate 3. It passes through N. So the circle passes through N and A. So the key thing to already spot here is that they have the same x value, you see. So meaning this is a straight line going straight downwards, you know. Don't forget it. It's a straight line going straight downwards. They say it's C. You have point C over there. It's a point up there. And then you have B, which is -4 coordinate 2. B is over there. Then it says here C, D, and E are joined to form a parallelogram. C, D, E are joined to form a parallelogram. This is 6. Okay. Parallelogram such that BE parallel to that, which is parallel to the x-axis. And then it says here CD is a tangent to the circle, and then CD is 6. Well, they didn't say this is a rhombus. They said it's a parallelogram. So anyways, let's see, for 1 mark here, what do you want? Write down the length of the radius of the circle. So the length of the radius of the circle, as we said, it's just going to be this, because this is a straight line going straight downwards, because the same x value here is the same one there. So this line is not slanted or anything. So the distance between this -1 and this 3, that's the radius. So it's a 4. Let's see here. Radius is equal to 4. Then they said here, calculate the coordinates of C. What are the coordinates of C? Coordinates of C. C is going to be straight upwards, you see, because I mean, like, if you think of it, this is a straight line going straight upwards, you know, because I mean, like, if this is a tangent, then this is like a 90-degree angle. So you know that this is 90 degrees, so going straight up down there is going to be 90 degrees as well. So if the x value here is -1, up here it's also going to be -1. The radius is like a 4, so like 4 upwards, that's going to be like a 7. You see, -1 and 7. That's why it's also just a 2-mark question. You see, -1 and 7. Very nice. Coordinates of D. Okay, D, what you get here, well, the x value is just 6 above the -1, so it's like going to be a 5. The y value here is the same as the y value over there. 3 marks everywhere, hey? We love to see it. But I guess this whole 90-degree shunt is part for C. I hope that didn't throw off too many people, because, you know, this is a tangent to a circle, so it's going to meet it at an angle of 90 degrees with the radius. So meaning this is a straight line going upwards. It's just some, what do they call it? Just like thinking outside the box a little bit, but not too much really. Let's just put the coordinates of D over there. 3 marks here, they want the area of A, B, C, D. What's A, B, C, D? A, B, C, D is the whole, no. A, B, what? A, triangle A, No, triangle BCD. Yo. Me, I was lost there. I was lostified. Lostified. Lostification. It's just lost. Let's see. Triangle BCD. Where is BCD? Let me look for BCD here to get a nice color for it. Purple. Where is BCD? B C. Okay, so BCD is going to be half of this parallelogram. That's like all you have to remember. Remember, the area of a parallelogram is length times. It's going to be, base times perpendicular height. You see, that's the area of a parallelogram. Don't forget that. You see, it's just this with this, and then this, and then this, you see. So it is purely just this distance here times this distance here. You see, h here times the base. So for you to get the area of this triangle, you're just going to cut your area of your parallelogram in half. You see, so let's get the area of the parallelogram and then cut it in half, my friend. Let's see. So the distance from this point going upwards, what you gonna do now? Because this we already know, at least it's a 6, you see, for BE. BE is 6, but then from here going up, we can use this y value. This y value is a 2, upwards is a 7, so this distance is like a 5. You see, from 2 here upwards up to 7, that's like 5 units, and then from here that's like 6 units. Okay, very nice, very nice, very nice. So we have 5 here, 6 over there. So the area of that whole thing, remember, so the area, yay man, area of what? Of BCDE. B, C, D, and E, it's just gonna be 5 times 6, and then that's like 13, and then the area of triangle BCD is gonna be 30 divided by 2, which is gonna be like 15. Okay. We'll have to see it. Very nice. Very nice. That's 3 marks. So 4.3.1 here, 4.3.1 here, that's like a 3-mark question. Moving on, it says, the circle centered at N is reflected about the line y is equal to x. Okay, the circle centered at N is reflected about, this question, I think I remember doing this question, or a similar question in like the what? Was it not in the either the analytical geometry course, or it was in the June exam or something? So they say here the circle centered at N is reflected about the line y is equal to x. Oh, dang it. Reflection. Your inverse, I mean. So if it's reflected about the line y is equal to x, this is what it's actually going to look like. Let me finesse this circle for you real quick. Flex my skills that I don't have, So let's see here. Let's make this a bit short. Move this over there. So this is your circle, né? So if you're gonna reflect it about the line y is equal to x, right? You're literally gonna see something like this. You see, like this point here. There is what your circle is gonna look like. Tossed away. I like it. That song is gonna make me sound like such an idiot. But anyways, this is the line y is equal to x, né? So you're talking about the inverse of this circle. Zoop. Let's see here. So that being said, M is the center of the new circle. So remember, if it's inverse, you have to remember that everything swaps around. If the original center is like -1 and 3, this is going to be swapped around, So it's going to be like 3 and -1. You see, 3 and -1, as you can already see. That's the center. This is where M is. Secondly, it says here, this phone. Stop vibrating. Ish. Let me put it on silent. Let's see. So, what you got here? M is the center of the new circle, which is formed. The two circles intersect at A and F. Well, these two circles, it means that they intersect here. You see, there's A over here, F is going to be a point over there. F is new, but then E has always been there. I mean, F is new, but then A has always been there, because you see A here is already -1, coordinate 1, meaning that it's definitely a coordinate that is on this line over here. So next it says here, all this being said, calculate the length of MN. Come on now. M, we already said it's 3, coordinate -1. N, we said it is -1, coordinate 3. I mean, distance formula things here, you know. Oh well, it's all good. Mn is just going to be equal to square root of 3 minus 1 over there, -1 minus the 3 over there. Let's see what we got. You know. I hope I'm not making these dumb errors, you know, because dumb errors are not nice, man. Like, now I'm saying, let's see, this is also going to be -4 squared. So it's like 16 plus 16, eh? Nice. It's 32, square root of 32. And that will be that, you know. Yeah, so fun, eh? Seems like a fair paper, you know. Seems like a fair paper. Not too difficult-ish. Not too crazy, you know what I mean. So let us not be crying too much about it, because yeah, man, I'm like, you know, it is what it is. So yeah, let's see here. Nothing seems to be too crazy over here. Yeah, so far so good, you know. So far so good. The midpoint of AF. The question would be, what is F in the first place? Because I'm like, you know. But the nice thing about F is that the X value is going to be equal to the Y value, you know, because it's a point on the line Y is equal to X. So I could actually just use the what? Yo, bro. Yeah, Lipai, 4 marks. Get us the midpoint. Well, if instead of us worrying too much about F, what we can just focus on is the line MN, you know. That's my thinking so far. Because if you look at the line MN, the line MN joins N and M. And then what we already know is that M and N passes through the midpoint here, somewhere over there, you know. So what I can do is, let's just get the equation of M and N, and then find the coordinate of the point of intersection between this equation and the equation of Mn. You see, because the point of intersection of the equation of Mn and this equation here, that's going to be your midpoint. So let's get Mn, the equation of Mn. Getting the equation of Mn, it's just a straight line graph. Mx plus c, remember y minus y1, m, and then x minus x1. The thing is, we need the gradient of Mn first, you know. So the gradient of Mn, where is M and N? So let's see here, y minus y2 minus y1. So let's see, -3 minus that. I mean, -1 minus 3. 3 minus 1 over there. What you get? This is like -4. This is like -1. So firstly, what you get, what you need. This is like -1. So that's the gradient. Now you just need one coordinate. Let's use this one, 3 and -1. So it's like 1 and that, and then gradient is like -1. X value here is just x. We need, let's see, we used -1 there, so we need to use 3 here. There we go. Is good, eh? Dude, what the hell, bro? Everything's just going normal, and then out of nowhere, somebody just can't stay put. Well, maybe it's because the boy is excited about something, you know, like something very deep is going on, and it's so exciting. But it's deep at the same time, but it's so exciting, you know. One day is one day. I shall reveal it to you. But I think I've revealed it to you already, like let me not get too deep, like whatever. -x here. 3 minus 1, that's like a 2. So that's the equation of this line here, the red one, you see. y is equal to negative x plus 2. It kind of makes sense because it's like, oh, look at that. You see, that's a positive 2 right there. Nice. Y-intercept. So you want to check out where it intersects with this line here. So the other line here, we can see it is the line y is equal to x. So we know that y is equal to y. So let's do it. You know, y is equal to y. So here we can say negative x plus 2 is equal to x. All the x's on one side, you're gonna have 2 here. It's equal to like x plus x is like 2x, and then your x value is like a 1. So the x value where the x value of the point here is like a 1. So you can just get the y. So if the x value here is a 1, the y value also is a 1, because you can just throw it into that equation over there, you know, or you can just throw it into that other one. It doesn't matter, so that it's maybe less confusing. So here you're gonna say y is equal to negative 1 plus 2. That's like negative 1 plus 2. That's like what is negative 1 plus 2? Negative 1 plus 2 is like a 1. So therefore the midpoint is like x value 1, y value negative 1. Whew, yeah, that's deep, man. That is just like so deep. Okay, no, it's not that deep, bro. Like, come on, man. No, but they have to be the same, bro. That's a positive 1 and a positive 1, bro. What you doing? You were about to mess up so good. After flowing so nicely. Come on, man. Huh? Nah, fam. Okay, 5. Let's move on to question number 5. Without using a calculator, simplify the following expression to one trigonometric ratio. It's a 6-mark question. Whew, okay, let's dive right into it. Huh? So one thing, this is close to 180, so you know that you just want to break down your numbers. If they're already small, don't do anything. Sine 360 minus, so you can just use the cast diagram. 360 degrees minus lands you in this quadrant where sine is a negative. Don't forget your brackets, otherwise you're gonna cry. And yeah, no crying aloud during the paper. It's not good for morale. And then here, negative 10, the negative can just go outside, you know. So again, don't forget brackets so that you don't get confused to see that this is like one term and stuff like that. So this here, you can obviously see this is just going to be like sine 40, because 180 minus lands in this quadrant where sine is a positive. This times this is going to give you a negative thingy, so this negative you can put it in front there. Same idea here, these two multiply together, you can put the negative in front there. You see, cos 50 10x. Now for 6 marks, I really don't know why this is a 6-mark question, because it really doesn't seem all that. Because look, these two, I mean, like where there's fuel there's fire, you know. So you can change this one to a cos. Let's see, cos 90 wait, sine 40 is the same as cos 90 minus 50, you know, because from sine you can go to cos if you use the 90. No, bro, don't lie. What am I saying? Hey, let's just go back to the drawing board. Sine theta is the same as like cos 90 minus theta. So what am I trying to do now? Oh, so this is gonna be like cos 90 minus 40. This is like sine x. The whole thing here, cos 50 10x. Remember, 90 minus 40 gives you a 50. So you have cos 50 at the top now. Sine x here. Okay, now I see why this is 6 marks. It's 6 marks not because it's like complicated. It's just 6 marks because I mean, like, you know, you're gonna need to get rewarded for the steps, you know. So this is like sine x, right, divided by 10x. 10x is basically like sine x over cos x, you see, of which you can just flip and multiply. Sine x over 1 times this over, like that, you know. So this is going to give you this cancels that, then you're gonna have your cos x. Here's the final answer. Nothing crazy, so it looks like it was very good 6 marks. They say you should prove the identity. Well, this is a square, is it not? Yes, it is, my bro. Okay, prove this identity. Okay, fine. We can definitely prove this identity. What is this identity? Wait, prove the identity. This. Oh well. So anytime you have a number bigger than 360, just remove 360 from there, like automatically, without doing any funny business. Up here we see there's a sine squared x and there's a cos somewhere. So just from what I'm seeing, it looks like, see the mark allocation 4, so it's not too bad. It looks like it may be easier for us to change this to a cos, right? 1 minus cos squared x plus cos x plus 1. And then the whole thing here over 1 minus. So remember we say you can just remove 360 from that without worrying about anything. So it's like 540 minus 360. 540 minus 360, that's like 180. So this is going to give you 180 minus x. And then here it's like, let's see the next step. Negative 2 times 1 is like negative 2. And then plus cos squared x plus cos x plus 1. And then here it's like 1. So it's like cos 180 minus. Remember, 180 minus leads you in the quadrant where cos is a negative, you see, because this is the quadrant 180 minus, but cos is a negative here. So this negative is here, né? But then you're multiplying by a negative cos x over there. Because we're just dealing with the left side, trying to make it look like the right side. So having to have done all this, I'm like, so far so good. Check for errors, because like you don't want to just, oh, error over there. You see, error. This is supposed to be a 2 there. Yeah, error. Yeah, we found you. You thought you could just go without being seen. Yeah, I just realized I haven't listened to Trevor Noah say anything in so long. Yeah. 1 minus 2 is like negative 1. So here I can foresee some funny, some funny factorizing whatever thing here. Because I mean, like, this could even give you a hint, like legit. Like, don't take these hints for granted. You see here, and this down here, I mean, like, and then this here up here. This up here, it looks like we can factorize it into 2 brackets, where literally this is one of the brackets and this is the other bracket, like legit, because it looks as though the top is going to have this and this, and then this is going to get cancelled by one of the brackets at the top, and then this is going to be left. So to make better sense of it, if you're looking at this nicely, you could think of it as like 2x squared plus x minus 1. If you're going to factorize this, you need to look for you need to say this times that, right? It's going to give you like a negative 2x squared. And then you need to get factors of 2 that can give you a 1. It's just going to be 1 and 1. But then to get a negative 2... No. Whoa. Factors of 2 that can give you a 1. It's going to be like 2 and 1. And then to get a positive 1 here, it has to be like a positive 2 minus 1. Then you put an x here, you put an x there. Do this, yeah, like that. So this term in the middle is just replaced by these 2, and then you're going to put a minus 1 here, and then the plus 2, and then the 2x squared in the front. So what I've done here, this is like a method you can use to factorize using grouping, because just take these 2, you multiply them together, you get a number. This number, you want to split this up into 2 factors that can give you this number in the middle. So that's like 2 and negative 2 and positive 2 and negative 1, because positive 2 minus 1 gives you this. Here you can take out 2x as a common factor. It's going to give you x plus 1. Here you can take out negative 1 as a common factor. It's going to give you x plus 1. Then here you can take out x plus 1 as a common factor. You're going to be left with 2x minus 1. So where x is here, right, you can see here we just have cos instead, you see. So what you have here, you can just write a cos where x is, and then you can just carry on, you see. So this is going to be like cos x plus 1 factorized, and then 2 cos x minus 1 factorized. The whole thing over 1 plus cos x. As we said, you see, sometimes even if you couldn't see this, you could have just guessed it. Not guessed it, but you know, this should guide you. So this here cancels the bottom part, and then you have here equal to 2 cos x minus 1. Therefore, the left hand side is equal to the right hand side. Is all good. So that's that. 5.3 here says sine 36 is equal to this, right? Without using a calculator. Determine each of the following in terms of p. So this is just a right angle triangle that you're gonna need to draw. Nothing crazy here, like really, because this is like 36. This is gonna be opposite over hypotenuse, right? So it's like opposite over hypotenuse. This value here, you can just use you can use Pythagoras theorem to get it, because let's see, 1 squared is equal to square root of 1 minus p squared times x squared. This has to be squared, and that also has to be squared. No, bro, it's a plus, my guy. Come on, man. Come on now. Just flowing nicely here, about to make dumb mistakes. So anyways, the square root cancels the square there. Then you're gonna have this here, and then everything to one side. You're gonna have like 1 minus 1, right? So that's like positive p squared left, because everything goes to the left here. Square root both sides. You're gonna have here x is equal to p. Okay. So here it is p. Okay, you have a shape, you have question, you give answer. So 10 is like adjacent of hypotenuse. So 10 36 is like adjacent, no, opposite of hypotenuse, no, opposite of adjacent, bruh. Oh heavens, another hour of algebra. Yo. Yeah, I was already getting lost there. Lost dead, huh? You know, lost. Yeah, I think it's a series or something. I mean, I don't know it me. But anyways, moving on. What is this thing? It's like cos 108. What is 108? Cos 108. Well, this number seems a bit strange, but what I like to do is to find out what this is, you see. So let's see, 90 minus 36. That's going to give you 54. Yeah, that kind of makes sense, because remember, 54 is half of what they have spoken about here. So you just want to finesse this question, you know. This is the same as cos 2 times 54. You see, remember, this is just a double angle. With your double angles, you know that cos with a double angle, I mean, like, you can choose whatever you want. It looks like the easiest one would probably be like, I don't know, 2 cos squared alpha minus 1. So let's use that one, you know. Where alpha is, we have 54. So this is like cos 2 times 54 here. Let's see, this is going to be equal to 2 cos squared, the 54 here, minus 1. So this is going to be 2. Cos 54 is just adjacent over hypotenuse, but then it's squared, you see. So it's like adjacent, which is this value here. So you see, cos 54 here is hold it on, let me make it make sense. It's adjacent over hypotenuse, so it's just this value over 1, but then it's squared, you see. So that's why you have to square it here, and then minus 1. If you simplify, you're gonna have 2. This square root gets cancelled by the square there, you have 1 minus p, like that. If you simplify, you're going to have 2 minus 2p squared minus 1, and then you're going to have your negative 2p squared plus 1. That's the way. I like it. Hey, just fooling around here. Don't align, eh? These questions were flowing. Yo, sure, such a nice paper though. Yeah, this paper was just like cake, man. Like, you know, cake. You know, you like cake? I like cake. I don't know about you, but yo, I love cake. But anyways, hey, let's move on. Let's see. Question 6. You're not my way. Look at this. Use the given identity to derive a formula for cos alpha plus beta. So this question, you really don't need to overthink it too much, you know, because I'm like, you know, yeah, don't overthink it. Just split up the plus beta into minus and a minus. So here you're gonna have cos alpha minus negative beta, and then you're gonna use exactly this formula. You see, because firstly, where you see this plus here, you just need to have a minus and a minus, and then you're just gonna use this this formula that they have. You see, something minus something gets expanded into this. So here you're gonna put the cos, right? So it's like cos alpha, cos this angle here, and then plus sine alpha, and then sine this angle over here, sine that angle over there, minus beta. Okay, let's move the on. So here this is gonna be equal to, remember this is the same as cos with a positive beta, cos alpha, cos with a positive beta. This is the same with the negative sine alpha. So let's just do it step by step here. Sine alpha being multiplied by negative sine beta, then these are being multiplied together, right? So you have cos alpha here, cos beta here, minus sine alpha. No, yeah, it's a minus here because a plus and a minus gives you a minus, and then it's like sine beta over here. Okay, this is what you got. It's nothing crazy, nothing major, nothing crazy. Yeah. Hey dude, come on man, relax, you know, relax. Hey, let's move on. Simplify completely. Yo, 5 marks though. Hey, yeah, ne? Yeah, but so far so good with this paper. I don't see too many crazy stuff going on here. But now we have 6x and 4x and 10. To be honest, I don't want to panic because it's like, what's the point, you know? There's really no point in panicking. So this here is trying to make me think of, you know, some double compound angle, whatever stuff. Because I mean, like, you know, there is 6 and 4 and there's a 10. So let me just do this. This here, let me rewrite it as 6 and 4 and see what comes out, you know. 2 cos 6x cos 4x, you see. Let me write this as like cos 6x plus 4x. You know, where there's fuel, there is definitely going to be, where there's fire, there's smoke. Where there's smoke, there's fire. Hey, I think you get what I mean. What I'm trying to say is, I'm like, don't take the 10 and the 6x and the 4x for granted. I'm like, you know, why is it 6 and 4 and there's a 10, you know? They must be linked some way, somehow. So here, let's break this up using what you call this formula, because remember this formula here is the same as cos alpha plus beta. So here you could just have 6x and 4x over there. So here you have your 2 cos 6x cos 4x that you originally had. This, if you expand it, you are going to have cos 6x and cos 4x, cos 6x cos 4x, and then here you're gonna have sine 6x and then sine 4x. That's this thing expanded. Then you're gonna have plus 2, let's see here, 2 sine squared x. Okay, then you have here, let's just multiply inside, the negative has to be multiplied inside there. So it's like cos 6x here, cos 4x minus cos 6x here, cos 4x plus sine 6x sine 4x plus 2 sine squared x. Anyways, so this minus this leaves you with one of them, because these are like terms here. So this is going to be cos 6x cos 4x plus sine 6x sine 4x and then plus 2 sine squared x. So these two here, let's try and see our formulas. See, these two, it looks like this, so it's like alpha minus beta over there. So it's going to be 6 minus 4x. So these here can be written as cos 6x minus 4x and then plus 2 sine the squared the x. This is going to give you cos 2x plus 2 sine squared x. Okay, so we want something that is a sine clearly, so you're going to use this one, 1 minus 2 sine squared x. This is from your formula sheet, because this is a double angle. I know my brain was like yo, wait, let me not try and off ramp too much. So this minus this, they're going to cancel out, because there's a minus and a plus over here, and then you're going to have positive 1 as the final answer. Very, very nice. 6.1.2 was not bad at all. Oh, it was quite an interesting question, really. I don't want to lie, it was like, oh, 7 marks. 7 marks. Hi, man. So it's a lot of marks in one question. So, hey, you're going to get those marks. Determine the general solution where cos x is a negative. Okay. Okay. Oh, well, let's see. 10x. What you gonna do? I'm gonna change it, obviously. Like, duh. This is gonna be equal to 2 sine. No. 2 multiplied by 2 sine x cos x. You see? To put this over 1. Let's cross multiply. You're gonna get sine x is equal to 4 sine x cos squared x. Okay, then you're going to divide both sides by the sine. You're going to get divide by sine x over here, divide by sine x over there. You're going to get 1 for cos squared x. And then 0 is equal to, no, bro. You're going to divide by 4 on both sides, okay? Come on now. 1 over 4 cos squared x. And then going to square root both sides. Cos x. Now you're going to get a reference angle. You see, the reference angle is going to be equal to shift cos with this value here, and then what you get is the reference angle. So remember from here, because shift cos this value is going to give you a reference angle. If this was a negative, you would always take it as a plus. So it's kind of tricky how you see here, it's plus and minus. So you may be thinking to yourself, but then what do you do then? Do you take the positive one? Do you take the negative one? Well, you have to remember, any value squared will always come out as a plus. Excuse me. Yeah, man, it is what it is, It definitely is what it is. So all this being done, let me just, be looking at it for a bit longer. And be thinking for, a bit longer. Because, the boy needs to get marks, sir. But they did say where cos theta is a plus, so you have to take this as a plus. Anyways, let's just get this reference angle and get it over and done with. It's going to be like a half. Shift cos a half. Gonna get like a 60. Remember, that's the reference angle. It's a 60. Now you can use where cos is a positive. So it's like, wait, where did they say here? Cos is smaller than 0. Highball. Well, they did say where cos is smaller than 0. Okay, fine. So if you look at where cos is a negative, so that's going to be in the 180 minus quadrant and the 180 plus. This one and this one. So let's see, 180 plus the reference angle. Let us see here. In the second quadrant, right, it's going to be your value of what? Is it x? Yeah. X is going to be equal to 180 degrees minus your reference angle plus K360, K element of integers. This is like 120. K360. K is the element of integers. Okay, perfect. And then which other quadrant? The third one, right? So let's do here 1, 2, 3. Let's see, 180 plus K360. K is the element of integers. 180 plus 60, right? What you're gonna get here? 240 plus K360. K is the element of integers. Yeah, these are your angles. So you're gonna get these two answers. And then, yeah, you're okay, you're okay. I'm like, you ain't gotta worry too much about anything, because I'm like, Ish, me, I'm just being a dum-dum. Like, I really am just being a dum-dum. But these are the answers. I know that just by looking at this, sometimes it's like a bit crazy. I'm like, yeah, these are the answers we're getting. But it's out of 7, So sometimes out of 7, you may be thinking to yourself, could you really have gotten more answers? Yeah, it's kind of crazy, man. It really is kind of crazy, because, like, another version of this, you could have factorized it. You could have taken everything to, like, one side here. Instead of dividing by the sign, you could have taken everything to one side, right? You would have ended up with this, cos squared x minus sine x. Then here you'd have taken out a sine x as a common factor. You would have had 4 cos squared x minus 1. And then here sine x is equal to 0, or you have here 4 cos squared x minus 1 is equal to 0. So this is what gave us our answer so far. The sine x equal to 0 part, you'd have done shift sine. Your reference angle there would have been as 0. And then if you're going to use a 0, you have to use where sine is a positive. So this would be in the first quadrant, right? So you'd have had x is equal to 0 plus K360. My goodness. Come on, bro. Come on, man. Come on now. Let's see here. X is equal to 0 plus K360. K is the element of integers. And then what else? The second quadrant is 180 minus. So x is going to be equal to 180 minus the reference angle, which is a 0, and then plus K360. K is the element of integers. For 7 marks, ne? Yeah, I think this one went a bit deeper. The first deep-ish question so far. Because I think this would have gotten you like a good 5 marks or so. So yeah, let's move on to question number 7. In the diagram below, yes, the diagram, this is drawn in the interval negative 180 to positive 180. Oh wow, it's nice. It's a negative sine graph, okay. It says on the grid provided, draw the graph of cos 6x minus 60 from negative 180 to positive 180. Clearly show intercepts with the x-axis. Well, why does it look so familiar, this question? So this is the graph of cos moved 30 degrees to the left. Cos x, no, 60 degrees to the left. This is cos x, right? Moved 60 degrees to the right, because you're minusing a number there. So the best way to do this is just, I'll draw it here. So if you're going to visualize a standard cos graph, you see it's going to go between 1 and negative 1, and then around 180 it would have, you would see half of it, you know, you would see something like this. Whoa. Yeah, this is hard. You would see something like this, and then you would see something like this, and then from here, right, it would then have gone like this, and then like, wait, you know, come on, bro. It would have then go like this and then like this. You see, this is a cos graph. Now this is if it was not moved at all, you know. And then on this side you'd have seen this side over like that, and then you'd have seen this side over like that. So all this being done, this is what it would look like if you have not moved it anyway. So this is saying it has moved 60 to the right. So moving 60 to the right, you have to look at this, and you have to look at this, and you have to move it 60 to the right. 60 to the right, let's see. So the distance here is like 90, right? So 60 to the right would make it go here. 60 to the right would make it go here. This is going to be like negative 30. And then this here plus 60 there, that's like 150. So you're going to take this yellow graph, you're going to move it 60 to the right. So let's do that. So from here, you're going to move it until it is there. And then voila, this is what you would see, right? On the left here, it would then go up a bit, something like that, and then obviously on this side is gonna be like that. It's gonna be chopped off. But if it ends there at 180, it's gonna be chopped off over there. And then now this is your picture. You're a picture over there, your picture over there. This is necessary, this is necessary. This has to go up to 1. This has to go down to negative 1. You know, you can give a coordinate here if you want, because the coordinate here, you have to remember it started off at like 0. So 60 to the right, this is going to be like 60 coordinate 1. This was at like negative 180, so it's going to move to the right 60. So you're going to put here, what is negative 80 plus 60? That's like negative 120. Negative 120 here, coordinate negative 1, you know, just to save your buttocks so that there is more accuracy. Okay, good. We love to see it. Let us move on. Clearly show intersects with the x-axis and the turning points. Oh, they say turning points. Hey, I'm just doing it literally just to be funky here, but I actually wanted it, so is good. Anyways, let's see. Question 3, write down the period of f of x 3x. Where is f? F is this graph here. So f of x looks like negative 2 sine whatever, negative 2 sine 3x. So your period always comes from the frequency, you see. The period is equal to 360 divided by the frequency. Your frequency is a 3. So period here is 360 divided by 3, 120 degrees. Okay, nothing crazy, nothing major. You are right, you get your marks, and you keep on moving, man. Like, ain't no time to waste. You know what you're doing, wasting time. For 1 mark here, let's see. Use the graphs to determine the value of x in the interval negative 180 to positive 180, for which f of x minus g of x is equal to 0. So they want you to work out where the distance between the two is like 1 unit. or you can just do it like this. Let's see here. F of x equal to 1 plus g of x. You see me. What am I doing? Complicating things. Well, it's a 1 mark question. They said use the graph to determine where. They basically want you to determine where the distance here is a 1, you know. So let me actually not complicate too much. You see, they want you to work out where the distance between the y values is a 1, you know. Distance between y values is 1. That's what they want you to do. They want you to work out where the distance between the y values is a 1. So, wow, are you gonna work this out by observation or what? Well, yeah, I mean, like, yeah. So this one's gonna be kind of weirdish because it is a 1 mark question, but they said use the graphs to determine the value of x in the interval negative for which the y. Okay. The y value of f minus the y value of g should be a 1. Okay. Wait, where is f? F is the sine graph. So let's see. The sine graph has bro. I don't want to do it algebraically, like legit. I really don't, right? I really don't. But then, if you look at it, this is the part, right, where the graph of f is above the graph of g. Yeah, man, like, this is like so crazy. Yeah, I think this is the first trippy question. I don't know why I say trippy, but it's kind of trippy, man. Like, what you say now? Like, what? This, that, what? This question is not very nice. Like, it's really not pretty at all. Like, oh, I ain't liking this question. No, like, I don't want to lie. But, I would work it out algebraically. But then if you're going to, let's say, like, take a good guess, not a good guess per se, but this is the only side where f is above g. You want a distance of 1. You see, this distance here, I mean, like, this is 0 minus something. It cannot be 1. Any distance here cannot be 1. You see, I'm like, look at it. It doesn't look like 1 at all. But then as you come closer to the left side here, you can just think logically about it, Let's come closer to the left side here, you see. Somewhere here, you see the distance between them is 0. So let's see here. This is going to be like a negative 30. So let's check what the y value is at negative 30 for the graph of f. Let's see what negative 30 is. Let's see here. F negative 30 in the graph of f, you're going to get negative. Is it negative sine 2? No, negative 2 sine x. Negative 2 sine x. Negative 30. Let's see what this gives us. This should give us a 1, right? Because it's like a half times 2. No. Negative a half times 2. That's like a 1. And then this is a y value of 0. So it's like 1 minus 0. That's definitely a 1, you see. So this one is a 1 here. And then for the graph of g, where you throw a negative 30, this is like a 0. So 1 minus 0 is going to give you a 1. So x is equal to negative 1. X is equal to negative 30. Where x is a negative 30, that's the only part where the distance between these two is a positive 1. You see, this here it's a 1, this here it's a 0. Whew, okay. That one was kind of annoying, but we are done with it, so let us move on, huh? No. 7.4 is the next one. 7.4 says for 2 marks, write down the range of k if k is this. So you have to know what's going on here. Firstly, here the amplitude was halved, and then it was moved. The graph itself was moved 1 unit up. So amplitude here was halved. How do you spell halved? Is it with the F with the V? My guy, halved. was halved with a V, and then here it was moved 1 unit up the graph. You see, it was shifted 1 unit upwards. So shift 1 unit up. So if this was shifted 1 unit up, what do you have now? Let me move this 1 unit up. The yellow graph, let's move it 1 unit upwards, right? We need to move the yellow graph 1 unit upwards. Yellow graph, move 1 unit upwards. Okay, the range. Okay, well, this is how many marks is this? Because it's only 2 marks. We don't have to overthink anything. Like, legit, bruh. Like, come on now. Because if the amplitude is halved, then you have to remember that your graph, let me actually show you the steps. Your graph would have looked, instead of going down here, it would have gone there, it would have gone up here, and then it would somewhat still pass through there and there. So it would look something like that and that and that and that. This is if you have just halved the amplitude. But then if you then move it 1 unit upwards, then your graph would let's see, oh wait, I need to carry it on like this, see, like that. So if you then move this green graph 1 unit upwards, then you see here this is like a half, you see. So if you move it 1 unit upwards, it's gonna be like 2 halves up, so meaning it's gonna be cutting there at like a positive a half all the way until like 1.5, because from the amplitude is like a half, you see. So from here to like the resting point, it's a half, and then it's like also half a unit upwards. So from here it's going to be from positive a half until 1.5. That's what your green graph is going to look like. I know it's not much to scale, you know, it's not the best, it's really not the best, but then that is the best that I can do for now, you know, so that we can move on with our life, because you really don't want to dwell too much on these kinds of questions. But yeah, that's the range, you see, from a half until 1.5. So let's say here the value of y is element of a half until 1.5. There we go. That is going to be a range for 7.4. So if you want to go through it again, feel free to do that. That is why recordings are there, so that you can rewind and everything like that. Obviously, if you need more info or if you just need more clarity, you can always hit me up on IG and I will respond as soon as I can, you know, depending on the number of DMs. Oopsie. Why am I crying? Was I crying or laughing there? I guess we'll never know. Anyways, 3D triangles. This sounded kind of I was about to say kind of boring, but I should stop saying that. In the diagram below, T is a hook on the ceiling of an art gallery. Okay, points Q, S, and R. Q, you have Q here, S here, R here, are on the same horizontal plane from where 3 people are observing the hook. Okay, for where 3 people are observing the hook at T. Then it says that the angle of elevation from Q to T is X. And then it says here QSR is 90 plus theta, so it's like 90 plus theta over there. And then it says here QRS is equal to X over here. And then it says here QR is like 5 units over there. And then it says here TS is equal to SQ. Whew, such a lot of stuff. Anyways, for 3 marks here it says prove that QS is equal to 5 10x. QS is equal to 5 10x. Well, don't overthink it, you know, like there's really no need to overthink this. I'm like, hello, you know, if this is you have an angle, you have a, let's see here, angle and then opposite side, and then you have angle and then you need opposite side, so that's just going to be the sine rule, you know. So the sine rule, so it's like, since you're looking for a side, right, it's easier to put the side on top. So QS is the side over sine the opposite angle, that's like sine x. And then here, so since you have the side QR, you can put QR at the top, and then the opposite angle is sine 90 plus x there. Sine 90 plus x. So we just use the sine rule, you see. The side with its opposite angle, side with its opposite angle. That's why this is not like difficult or anything like that. So this is like QS sine x. I'm pretty sure you can tell that my energy levels are like running out, man. The boy is running out of energy. But yo, it is halted on. 90 plus is like cos, right? So this is like cos x. Okay, so what do you need now? We need what? Your now QR is 5, bro. So let's just put a 5 over here. Let's put a 5 over here. So let's QS on its own, you're gonna multiply by sine x on both sides. So QS here, this is gonna be equal to 5 sine x cos x. And then that would be like a 3-mark question. No, this is going to give you a 10 because sine over cos is a 10. You see, this is, then you're going to have QS is equal to 5 10x. Good, nice. So whatever you get, normally you just want to put it there on your sketch, you know, because like, trust me, you're going to usually need it. You put 5 10x here, 5 10x here. And then remember, if this angle here is x, it means that that angle there is also equal to x because, you know, isosceles triangle shandies, eh? 5 hallmarks here. It says prove that the length of QT is 10 sine x. Okay, this doesn't look so bad. I mean, like, it's 3D triangles after all, you know. Where is QT? QT, where are you, bro? We are wanted. We are wanted, you. So the thing is, there's a sign over here. So yeah, but there's a 10. Well, just keep it simple, you know. You have an angle with another angle here. You have a side with another side. You don't have this here. This is open. So I would probably be thinking to myself, are we going to use the cosine rule? Yes, we are. Because the reason why I would use the cosine rule here is because we can get this angle. This is just 180 minus 2x. And then we have a side given here. We have a side given here. And we're looking for an opposite side. So let's use the cosine rule. Cosine rule, you can just use your formula sheet. Remember, your formula sheet, whatever you do on your formula sheet with the cosine rule, this angle here, which in our case here is like QT, I mean, this side here is the side that will be on its own. This will be the angle that will be on its own. So it will look like this. QT squared is equal to these two sides here. So it's going to be TS and QS. It's going to be here TS squared and QS squared minus these two put together. I mean minus 2 of these two. And let's see here, 2 TS QS and then cos. What's the angle? The angle is this one here in the middle, you see. That's angle S. That's like 180 minus 2x. So it's like cos angle S. What's that angle specifically? It's going to be QST. QST. Okay, now let's throw in our information. QET, we need it, so we can leave it open. This is going to be 5 10x squared. Another 5 10x squared minus 2 with 5 10x. It's going to be 5 10x and then another 5 10x. So this is going to be squared. And then cos 180 minus 2x. So this is actually quite an easy 5-mark question, because I mean, like, you know, don't be in a hurry, you know, just do it nicely. 5 squared is 25. 10 squared is just 10 squared, and then here 25 again, 25, 10 squared x, and then this is like minus 2. This is like 5 squared, right? That's like 25, 10 squared x, and then this is going to give you 180 minus, what is 180 minus? 180 minus is like cos 2x, like that. And then here you're going to have the this plus this. These are two things that look alike, so it's like 50 10 squared x, and then this is going to be negative 50 10 squared x. Don't make the mistake of working these two together, because there's a cos 2x over here, so you can just merely take it out as a common factor for now. 50 10 squared x comes out as a common factor, but why? This is just crazy, eh? Let's see what we're trying to work out to this. It's crazy, eh? Yeah, it's crazy, bro. Like, my bro, it's hot. It's really hot. Like, you're like a heater. But let's see. 50 10 squared x, 1 minus cos 2x over here, and then this is like qt squared. And then let's see here, this is like q t squared, né? And then you're gonna get here, let's change this to something that has a 1. Since we're trying to work towards sine, I mean, let's keep cos's here, so that we might end up cancelling. What here? Let's see, let's just change this to something, you know. But then you wanna be strategic as well, because now I'm thinking to myself, there's gonna be there's gonna be sine squared here and cos squared at the bottom. So since I want to end up with something that has a sine, I mean, like, let's maybe change this to, like, I don't know, something with a cos squared, but I don't think it should be too much of an issue. You see, 2 cos squared x minus 1. I was answering this question. I just keep going in. I'm like, this question, is it working out, madam? Is it working out, this one? So let's see. If you multiply inside, it's gonna be 1. I changed my mind. Let me change this to, like, the one with the sign. Don't be afraid to change your mind, né? If you see it's not working, my guy, change it, man. Change it. Why should you stick around with something and suffer, man? Change it, my guy. Change it, like a light bulb or whatever you change. So that's weird, bro. So anyways, let's see here. This is gonna be 1. Don't skip steps, my guy. 1 minus 1. So it's gonna be multiply negative in there. This is what you're gonna have, and then you're gonna have here qt squared is equal to 50 10 squared x. 1 minus 1 is a 0, and then this is like 2 sine squared x. Esan. Heish. What is going on here? Let's see. This is going to be 50 sine squared x, the whole thing over cos squared x, because the 10 can be changed to this. You're multiplying by 2 sine squared x over cos. No, bro. This is over 1. Ish. Yeah, this is tricky, eh? It's tricky. Now I'm thinking of the cos instead. Yeah, man. Yeah, it's like so harsh. It's like so hot here. Like, the heater joke is not even working anymore, because now I'm just like, let me just carry on. Let's just carry on, guys, and see what happens, you know? Let's see. This is gonna be like 50, because it should still work out at the end of the day. I mean, like, it shouldn't be like too much of a train smash. If you square it both sides, Sure, nah. Should end up with 10 sine x. I hope I didn't make like a big mistake somewhere. Now I'm just like swimming in a mess, like like when you make a mistake somewhere and then you just keep going in circles, and then I'm thinking, why did could I not have used, like, I don't know, the sine rule or something? And I think I could have, but I could have. Hey, you know what, name? I'm going to accept defeat here. I'm going to be humble, because let's see, side and opposite angle. Okay, I've accepted defeat here. Like, I'm going to be humble and say that, you know what, let's just use the sine rule, because there's just too much nonsense here, so he's okay, you can hate, but me, I'm not going to cry and just carry on with something that looks like it's just going forever, like, take the L and be like, sine rule, please help me. So let's see, so sine t and qs, let's do them together. So let's see here, sine t over qs, let's do this. Then here it's like sine qst and qt. Let's see here, sine qst and qt. There's qt over here, qt. And then what you're gonna do here, sine t. So sine t, that's like sine x, right? So it's like sine x. Qs, we have 510x. This is equal to sine 180 minus, yeah, 180 minus. Yeah, this looks so much better. I mean, like, I feel like sometimes I'm just addicted to the cosine rule. Hey, be easy with the cosine rule. Just be easy. Like, hey. Like, is it really that special, bro? Like, you had to go so hard. But anyways, let's just carry on here. This we can work out first, because it's like sine x over 5 sine x over cos x. Then here 180 minus, that's like sine 2x with a qt over here. And then so far, you bro, how are you? Why are you wasting so much space? Hi man, no. Hi Bongani, no man, no Bongani, what is this? Hi, nah fam, nah, this is not on. This is not the way, eh? It's not how you were taught. Day in primary, remember they taught you how to write in cursive so that you can write fast and save space. All that nonsense that they lied to us, telling us. Like cursive, why did we even have to learn how to write in cursive, guys? Like, some pure nonsense. School, I know. Anyways, let's see. So here, what am I gonna do? I'm gonna cross multiply. So I'm gonna have qt here, sine x, and then 5 sine x sine 2x with cos x. I just cross multiplied. You see, this times the bottom, this whole thing times that. And then let us carry on, man, So we're gonna have qt here. Let's just divide by sine x on both sides, because one qt on its own anyways. So yeah, so we're gonna have sine x over here, cos x over there. So we divided by we divided by sine x on both sides. So 1 here can cancel 1 there. Then you have 5. This 2 here can be 2 sine x cos x. Oh, look at this, so much easier. Hey, this boy, he was busy just doing the hard stuff for nothing. Magangi. Nah, bro, nah, don't do that. So this is gonna be 10 sine x. You can do this cancelling because all this is just together, it's not like split up by plus or minus or anything. Anyways, 2 marks here. Let's see, calculate the area of TQR if TQR is 70, X is 25. So TQR is TQR. T here, Q here, R over there. You need the area of that triangle. TQR needs to be 70, X needs to be 25. Well, you know, we can use TQR. How many marks they give here so that I don't overthink? It's just 2 marks. Area of triangle TQR. I'm thinking of, excuse me, I'm thinking of, like, you know, the area rule, but at the same time I'm like, area rule, but then we don't have an angle anyway, but we just got TQ, you know, this is just 10 sine X, so we have side. Do we have the full angle here? We don't have the full angle over there. Yeah, this one is kind of, it's another trippy one because it's like TQR. Yo, man, come on, man. Why you gotta do that? You know, why you gotta be so complicated? Like, ugh. Yeah, nah. Yup. Let us think. What question is this one? Question number. But then, you see the thing with 2 mark questions. 2 mark questions sometimes are just like a bit crazy, you know? No, they gave us an angle, man. They gave us TQR. This guy, why am I overthinking? They gave us the whole angle here. It's 70. They gave us X. My guy, me, I'm just overthinking it because I don't have anything. Hey. Come on, man. This is 70. This is 10 sine X. X is like 25, right? So this is going to be 25. And then what is this side going to be? This is going to be like a 5. So in your calculator, you're going to put here triangle TQR. The area is just a half. One side is a 5. Other side here is like 10 sine 25. And then you're going to need to put here sine the angle. Because remember, the sine rule says a half AB sine the angle. This is what the sine rule says. So here it's half, one side, another side, and then sine that's an angle that you're given, which is the 70 here. So let's put all this into the calculator. Let's throw it all in the calculator. Let's see what we get. We are getting over there 9.93. That's what we're getting. 9.93. There, that's your final answer. It's all good. So we're done with 3D triangles now. Fantastic. Oh, Euclidean. Oh, this paper has been a bit long. Or it's just me that's tired. I don't know. Let's see. One more question, but before that, they said here in the diagram. Excuse me. PQ, R, and S is a cyclic quad. And duh, because the 4 points are touching the cyclic quad. I'm sorry. I keep saying stuff like that. So if you see that the points are touching the circle, it's definitely a cyclic quad. I'm saying duh, not to like be mean. I'm just like, okay, paper, we get it. It's a cyclic quad. Carry on. Let's see. This says here PS is produced to W. Then it says TR and TS are tangents. So these are equal to each other. And then it says here they are tangents to the circle at R and S respectively. Okay. Then it says here this is 78, this is 93. So if this is 93, remember this should be remember 180 minus 93 is what this side is going to be, because opposite angles of a cyclic quadrilateral, they are, you know, supplementary angles add up to 180 degrees. So that is 86 if you ever need it. Just gonna throw it over there, and then if you're going to ever use it, just mention the reason, you know. Anyways, let's see. For 1 mark, give a reason why ST is equal to TR are tangents from the same point, my guy, you know? Tangents from the same point. The same point. Nice. Moving on. Question 2. Give a reason for the size of S2. Where is S2? Where are you? Well, I mean, like, this is an isosceles triangle, you see. SRT is an isosceles triangle. So, S2 is equal to 180 degrees or minus 78 divided by 2. The reason for doing this is angles opposite equal sides, you know. Angles opposite equal sides because you have an isosceles triangle. So 180 minus this divided by 2 will give you each of these two here. So let's do it, man. Let's do it. What you get here? 180 minus 78 divided by 2. 180 minus 78 divided by 2, that's like 51, right? 51. S2 is equal to 51. Then what is S3 equal to? Let's try S3. S3 is, well, you have to get S1 first, then we can use angles on a straight line. S1 is equal to 87. The reason is opposite angles of a cyclic quad Now, because of those opposite angles of a cyclic quad, you now have 87 here, and this is 51. So this one you can just angles on a straight line, you know. So S3 is equal to 180 degrees minus 51 minus 87. Yeah, you know, like as we're going through this paper, yo, it's so clear that this paper was just like pop and place, man. Like, okay, let me not be mean, eh? But I'm just giving you my honest opinion. Maybe I'm just too OP'd, too overpowered. But I don't know. But I can still tell when a paper is difficult, and this one, it's not. Angles on a straight line. I think it is actually kind of true that November papers are the easiest. Between June prelim and finals, November are the easiest ones. Angles on a straight line. Let's say here, straight line. The hardest ones, I think it's like prelims. Yeah, prelims usually chow. Question 10 here says, in the diagram, BE, where are you? BE is over here. Okay, there is BE over here. So, straight line things, eh? There's BE over there. And then they said here, and CD are diameters. Okay, so they pass each other here. These are diameters, so don't take it for granted, because, yeah, that's like a big deal, because look, if these are diameters, now it means that there are two 90-degree angles here, or quite a lot of 90-degree angles actually, because it means that this is 90, and then I'm actually changing the style of this one, because I'm like, why not, right? You know, gotta have a, hey man, no, come on, change style. Gonna get this here. Ish, fine, I'll just use the style that you want. Then let me just change style. Let me put like a red here. Done. So take a red here, do this there, make this go like this, make this go like that. Okay, what you got? It says here, yeah, in the diagram, BE, what diagonals of a circle? M is the center, yes. Then it says chord AE. Where is AE? Chord AE is drawn to cut CD. AE, they've drawn it to cut CD, F. Well, remember, if you have a chord, a line coming from the center of a circle cuts a chord in half if they meet at an angle of 90 degrees. So don't forget that. And then he says here, let C equal to X. Okay, it looks like there's quite a lot going on in this one, yeah? Why is AF equal to... we just said it. Let's say a line from center bisects chord at an angle of 90 degrees. There you go. That's the way. I like it. I can't help myself, man. Determine giving reasons the size of M1 in terms of X. M1 in terms of X. Yo. This one here. Why you want this one? Why you want this one? Oh. No. I thought I had it. Excuse me. Kind of ran away from me, you know. Well, this is... oh, okay. So this angle here is double this one. You see? Because an angle at the center of a circle is double the angle at the circumference. And then here you have a right angle triangle. So let's use that. Let's get A1 first. A1 is going to be 180 minus X minus 90. Let's get A1 first. A1 is equal to 180 minus 90 minus X. The reason is interior angles of a triangle. So we can see that A1 here is equal to 90 minus X. You see, A1 is half of M1 because of a law. A1 is equal to half of M1. The reason is angle at center of circle. I'm wondering why I gave myself such little space. Circle. Okay, what else? A1 here is equal to a half, and then what's the value of M1? M1 is half of A1, bro. Come on. So what, you can just divide by a half on both sides, right? So remember, dividing by a half on both sides gives you 2A1 is equal to M1. So therefore M1 is equal to double whatever A1 is. You see? Then this is going to give you 180 minus 2x. 180 minus 2x. There you go. Very nice. We love to see it. Anyways, so that's for 4 marks, right? 4 marks. The next one, prove giving reasons that AD is a tangent to the circle passing through ACF. Let's see where AD is. AD is a tangent passing through ACF. Well, this one is quite easy, because if this is a tangent, you have to use the 10 chord theorem. So you have to show that this is an angle with the tangent and the chord, and you have to show that this angle is equal to this angle over there. You see, because you have a triangle here, you know, and then here you have a tangent. So if you're going to have a circle pass through there, you know, wait, pass through where? Did they say ACF? Yeah. If you're going to have a circle pass through those points there, then you just need to prove the 10 chord theorem, you know. You just have to prove that the angle here is equal to the angle over there, you know. So, or you just need to prove that the angle here is equal to the angle over there. You see, like the one here, I think this one is the easier one. This one you can just prove it's equal to that one because they're both equal to 90 anyways. You see, so let's say here, yeah, how many marks is this? This is just 4 marks though. This guy is, hey, it's just too much, this. like way too much. Yeah, honestly, I think it's a bit too much, because I'm like, this is 90 clearly given. I'm like, hello, this is 90 clearly given. Hey, that's why these kinds of questions are boring, man. Like, not like boring, it's just like so annoying, like, you know. It's like in our face, but it's like, why 4 marks ACF? Maybe it's because there's not like an extension here or something, you know. It's not fair. It's not fair. So we can just either prove that this is equal to X by we can prove that AFD is similar to that's just so unnecessary, bruh. Like, I don't know, lie, eh? It just feels so unnecessary. But hey, this questions, you know, sometimes they're just, you know, they just want to be crazy, you know, they just want to be annoying, you know, they just want to be annoying. So I'm just gonna use the 90-degree one, because I'm like, that one is the easiest one, you know. So we're gonna say that CAD is 90 degrees. We have to tell them that CAD is equal to 90. The reason is angle in semicircle, angle in semicircle. And then we have to tell them that this CFA is 90. That's given. CFA is 90. That is given. CFA is equal to 90 degrees. That's a given. And then what else? Wait, CFA is 90. That's a given. And then what else? Hi, what you need, bruh? So there's C. Yeah, so if this is 90, right, and you've proven that this is 90, you just need to show that CA yeah, you see, the only issue is referring to like this other part here, you know. That's like the annoying thing here, you know. That's like the really annoying thing. So I'm going to make a construction, eh? Let's say construct AC AC what? A B C D E F. So let's say construct DAG, because G I'm gonna put it over there. Yeah, because this is just annoying. Let's say here const G A D. You see, so from that construction, it means that, you see here, it means that CAG is 90 degrees because angles on a straight line. CAG is equal to 90. Angles on a straight line, since the other side is 90. So you see, we've proven that this side here is equal to 90, and we've proven that this is 90. So we've proven the 10 chord theorem, you see. So here we can then say, therefore CAG is equal to CFG. CFG. What's the reason? The reason is 10 chord theorem. You have used the 10 chord theorem to prove what you have proven here. And then let's go to this 5-mark question, 10.4. 10.4 says, given that CF is equal to 6, where is CF? CF is equal to 6, right? And AB is equal to 24. Where is AB? The whole of AB here is like 24. Not to scale, clearly. They say calculate giving reasons the length of AE. Yeah, it looks like here we're gonna use some similarity shandies, like for sure. Yo, I can see it coming, because this is just some crazy piece of nonsense here, because I'm like, these triangles are definitely similar, like one way or the other, you know. They just look similar some way, somehow. How many marks is this question though? 5. How what? Oh, what? And now I don't want to keep scrolling up and down here, so I should just take a screenshot of this. let me just how I should just go back down here. Let me paste here. Let me crop this. Let's do that. Let's do this. Make this a bit smaller. Make this do that. Anyways. So let me just crop this out also, because I'm like, you know, why not? So let me make this a bit bigger. And let me just carry on. So they said CF is 6, AB is 24. Calculate giving reasons the length of AE. So you have triangle AEB over here. There's E up there. There's A here. And there's B over there. Like that. And then you have B here. This is 24. Then you have another one over here, right? This other triangle here. This is 6. And then this is also equal to 90. So, I mean, like with questions like these, right, I would lean towards similarity, proving that these are similar in some way. I mean, that we already have them both to have a 90-degree angle. So we just need another angle that's in both of them. You know, and the one angle I can think of now, I mean, like if this is X, is there a way that we can show that this is equal to X? Or is there a way we can show that this tiny one is equal to that tiny one over there? Yo. Yeah, is beating. Don't I lie to you now. Is beating, man. Is beating. It's not very straightforward, because I am thinking of similarity shandies, but let me see. Usually when these kinds of things come up, I always try to also remember what does the description say, because sometimes the description gives us things that we don't even. Oh wait, remember how the diameters of these two circles are the same? Like CD is equal to CD is equal to BE. Yeah, like those big triangles are definitely similar to each other. What did they want in the first place? They want the length of AE. AE is this big. Oh wait, AE is this. Oh, we don't have to get the whole of AE. To get AE, we can just get half of AE. You can either get AF or something. So just thinking of that, it's also what's like persuading me to like think more about similarity and everything like that. The only thing is, what's difficult is like proving that. Excuse me. Proving that this triangle is similar to this one, because what did I have here? CFA. So this is like CF here, and then A over here, and then you have AEB here. There's B over here. Let's see, there's B over here, right? There you go. Yeah, so there's CAF over there, right? I need to pause and think about this one, because yeah, see, it's beating. But let me not overthink it too much, because I mean, like, why not, right? Why? So let's see, with EAB and EFM, well, those two, hi man, this one is just, yeah, I'm not really liking this one at all, you know, like, I'm just going to pause and think. So carrying on with this question, I don't align him. It looks as though the only thing to do here is to make use of what we have over here. You see, there's this big triangle here. There's E, there's A here, and there's B, right? Oh, already I drew that one. The other triangle that looks like could be promising is like E, F, and M. So these ones here, E, F, and M, ne? You have to remember that this is like 90, this is like M1. So, let's see what else. So this big one and this one, you can just prove that they're similar. Let's do it like this. Triangle. Yo, bro, come on. Let's see. Triangle EFM. So the reason I'm going with EFM and the big one is because I'm like them giving us the 6 here. This is kind of throwing everything off. So let's just leave the 6 for now. You know, but the other issue is, you see this 6 here is part of the radius. Remember, AEB is the whole radius, and then this is just 6 and a portion of the line here. So what I'm trying to say is, one way or the other here, né? You know that EM is radius, and then EB is the radius twice, and then you also know that CM is your radius. But then this radius minus 6 is equal to FM. So there's something that we can do there. Triangle EFM, EFM, and triangle EAB, right? Triangle EAB. Triangle EAB. So triangle EAB. Let's do it. EAB. In these two triangles, we have to prove similarity. So as proving similarity, we're going to prove that E is equal to E. That's a common angle. So let's do it. E is equal to E, common angle. And then the 90-degree angle, you see, EFM is equal to EAB. So it's like EAB over there. Those are both equal to 90 degrees. Wait, hold on. We have to show that this is equal to 90 first. So let me just move this one line lower. So this being equal to 90, like EAB equal to 90, we have to tell them we know that. So EAB, this is equal to 90, angle in semicircle, angle in semicircle. And then what else? EFM is equal to EFM is equal to CFA, because they're vertical opposites, is equal to CFM, which is equal to 90, vertical opposites. Remember, we have already shown that this is equal to 90, right? Like CFA at some point in time, I'm pretty sure we did this. CFA, we proved it to be 90, and they gave it to us, right? Oh wow, even nicer. So we've proven that this is also equal to 90 because of vertical opposites. So then we can say here EFM is equal to EAB, because they're both equal to 90. So that one is now proven. That's more of a conclusion. So we've shown that two angles are equal to each other in these two triangles. We've shown that E here is equal to the E there. We have also shown that the F here is equal to the A over there. So this last angle here, we can call it FME. So we can say FME is equal to ABE. It's equal to ABE. If you look at the shapes, come on, bro, write nicely, man, write nicely, please. So FME is, there is FME here equal to ABE over there. So the reason here is just interior angles of triangles, interior angles of a triangle. So now that you've proven similarity here, you can then say, therefore, triangle EFM is similar to triangle EAB. The reason is just angle. I think, yeah, angle. So that being said, you can now write your ratios. You see EF over EA is equal to FM over AB, which is equal to EM over EB. That's the way. I like it a lot. So now the interesting part starts, because it's like, okay, now what, bruh? Now what? Uzoyenzani now, huh? Uzoyenzani. So remember, they want us to get what here? They want us to get the length of AE. Remember, AE is this big length over here. So AE, we have, let's see if there's AE anywhere in here. There is. You see, there's AE over there. And then let's see what else they've given us. They've given us CF. Is there CF anywhere here? Nope. But then what do we have? Well, CF here is 6. But then they have to remember that what else? What do we have of CF? We know that FM here is the radius. Okay, let's just make use of the fact that, let's see what lengths we have here. Do we have BE? BE is the diameter, ne? Okay, let's start here. BE is the diameter. Where is EM? EM is like half the diameter. Okay, so we can write these in terms of each other. You see, EM and EB is the radius and the diameter. Let me show you. You see, there's EM here. This is the center. So EM here, ne? And EB, they have a ratio of 1 to 2, because remember, EM and EB, there's a radius here. You see, remember here, there's radius, and then down here, diameter. Remember, the radius is always half the diameter, so the ratio here is just 1 to 2. So here we can just write EF over EA here. This is equal to EM over EB. What we already know is that the ratio here is just 1 to 2. EF over EA, this is just equal to 1 over 2. The reason being, there's a radius and a diameter. The ratio is half, always and forever. Okay, let's keep plugging away and seeing what we can do here. Let's see EF. Where is EF? EF, we don't have anything, but then no. Yeah, I think this is where things get a bit tricky now, because it's like, what about CF? Where does CF come into the play now? So CF coming into the play, what I know is the radius is like CM. CM is the radius, right? Let's see FM. Is there a way we can incorporate FM? EF, I have EF here. Well, EA in particular, EA is like double AE. So yeah, we can write this as a ratio of each other as well, you see, because look, EF and AE, it's also like a similar thing. Oh yeah, 1 to 2. Of course. Dang it. I feel like I'm bombing out here. Ish. Bombed out. Let's see. Let's put a question mark here. But all this is correct so far. Just have to keep looking and seeing how we can get that 6 involved. But the one way we can get the 6 involved is if we use if we can get the 6 into the play here. As long as we cannot get the 6 into the play, then we are doomed. The other thing is AB. This whole 24 here, I haven't even used this 24 for anything. So let's see AB and FM. Where is FM? Yeah, let me just leave. It looks like this one and this one, they're not working out nicely. So let's just go back to the drawing board. What we do already know so far is that this ratio is also 1 to 2. But let's see. Let's see here. What you gonna write? Let's see here. There is EF over EA. This is equal to FM over AB. FM and AB. Well, remember, these two triangles are similar. AF and AB, there's a ratio here. AB and FM. And then you have EA and AE here. Actually, let's write what we have, EF, we have nothing. But then EF, I want to write it as half of AE. Yeah, let's do that. No, but then I'm going to have things canceling each other out and stuff. Hey. I'm trying not to panic. I'm like really trying to not panic here, you know. But I think let's forget about EA for now. You know, we'll do it. We will think of it later. So half of EA, right, is what EF is. Then you have EA up here. So this is going to be equal to FM over AB. FM is here. AB is 24. So you have to remember that the EA here is going to cancel the EA down there. You're going to have a half is equal to FM over 24. And then to get FM here, you're going to multiply by 24 on both sides, right? So you're going to have your FM is equal to 12. So let's see what happens if you have FM as 12. FM as 12, that's fine. So how are we going to use that to get EA? Oh, let's see. Wait, this is 12 plus 6. That's the radius. So it means that you can get this value here to be 18. You see, because of like that's the radius. EM is equal to the radius as well. So EM is equal to CM. So let's say here EM is equal to CM. They are both the radius of the circle. Let me show you again. EM is equal to CM. You see, EM here is equal to CM. They are both the radius. So this is like 12 plus 6. So that's 18. So because we know that this is 18, we can just use Pythagoras to get EF, and then EF twice is going to give us AE. Yeah, this question was hard. I'm not even going to cap. So let's do it. EM squared, doing some whole Pythagoras stuff here. So it's like EM squared is equal to, let's see, EM squared and then FM and FE. FM squared plus, where's that thing? FM squared and EF squared. EF squared. Let's see. So here let's put in our values, you see. This way I'd said it is equal to 18. So EM squared is 18. FM is 12. EF is 12. Let's put everything on one side. 18 square minus 12 square root here. This is EF. What is EF? So let's put in the calculator then. Yeah, you can already see yourself. This question was not normal. It was not normal. Because this one makes you think, but I'm about to cancel the thing. I'm about to cancel it, but I want to work it out. What? This is now 6 square root of 5. 6 square root of 5. And then we already know that AE is just double that. Therefore, AE is just double whatever this is, which is just equal to 12 square root of 5. Yeah, this question, I don't think, yeah, this is how you see this paper was not playing games. Okay, the Euclidean section clearly, because you like doggo, aye man. Anyways, that's that though. Let us move on to the next question. Question number 11. It says here in the diagram codes DE. Okay, where is DE? Okay, so you have DE over here, EF and DF. It says that they're drawn in the circle with center O. KFC. KFC is a tangent to the circle at F. And then they obviously want us to prove the Ten-Core theorem. You have 5 marks. Prove the theorem that states that DFK is equal to E. DFK, they want you to prove that this angle here is equal to this angle over there. Okay, so this question, I mean, like the one thing that matters most is the construction. You know, you have to construct the diameter of the circle first. So let's just do it here. You have to construct the diameter. It has to pass through O. So in your construction, right, like whatever you do mention, you need to say that the diameter is, you need to mention construct, let's say F, or let's name this A, F O A. Okay, let's name this F O A. Now the other thing that you need to construct is a line that goes to the angle that you're trying to prove, you see. So here you have to also construct like FE, you know, because this is going to be a 90-degree angle. So construct FOE and no, FOA, you know, FOA and AE. So you have to construct these two. So after constructing these two, what you're gonna do, you're going to need to make use of you need to label your items, you know. You need to label F1 here and F2. So let's say here label, how do you write label? Angle label, I think it's like this. So I'm gonna label this F1 and F2, and then I'm also gonna label this E1 and E2. So your point is to prove that E1 is equal to F1 over there using two theorems. You see, you're gonna use angle in a semicircle, and then you're going to use tangent perpendicular radius. So let's do it. You're going to firstly state that KFA is 90 degrees. So let's say you label F1. Let me just write them here. Label F1, F2, E1, E2. You see, label all these things here. Whether you write it out or not, it really is not a big deal, because I mean, like, if it's labeled, it's already a lawyer, you know what I'm saying? So let's see. So now you're gonna state that F1 plus F2 is equal to 90. You see, let's see it here. F1 plus F2, this you're gonna state that it is equal to 90 degrees. The reason is tangent perpendicular radius. You see, your tangent is perpendicular to your radius. Then you're gonna mention E1 is equal to E2, A1 plus E2, right? You're gonna mention that this is equal to 90. The reason is angle in semicircle, you know, angle in semicircle, just wait, me the like it, So they're both equal to 90, you've mentioned that. Now you just need to mention that F2 is equal to E2 because you have the angles in the same segment, you know what I'm saying? So why do I keep saying stuff like, you know what I'm saying? It's like weird. It's like, bro, like, no, stop it, man, stop it. Like, no, bro, no, stop it, please. So you have here angles in the same segment, you see, because you see they're both subtended by arc ED. If you hear any stomach rumbling, trust me, it's not your stomach, it's mine. Because yeah, I'm kind of hungry, man, but gotta do what you gotta do, man. So let's see. So E2 is equal to F2, right? So E2 equal to F2. Reason is angles in the same segment. So as long as you've proven that E2 is equal to F2, I mean, like, you're home and dry, you know, because I mean, like, if this is equal to this and these are both equal to 90, then you can safely say therefore, I mean, remember, if you've proven that this is equal to this and you've proven that they're both equal to 90, then technically these are going to be equal to each other, you see. So here you can then say therefore, you can actually make a calculation, you see. You can actually say here, therefore, F1 plus F2 is equal to E1 plus E2. Remember, F1 and thingy are equal to each other, so you can take everything to one side. You're gonna have F1 is equal to E1 plus E2 minus F2, and then here you're gonna have F1 is equal to E1, you see. And then you have proven here, you see. Now you can say therefore DFK yo, this mic string is on the way. Come on, I wanna write DFK. Sounds like the name of some airport in oh, it's JFK, but DFK, you know, is the airport in America. But let's see, these are equal, and then you're done, because this is the same as that. Nothing crazy with that theorem. I think it's actually one of the easiest proofs, the 10 code one. It's also on the channel, the main channel. It says here, let's see, oh, this diagram, please behave, but it says in the diagram PK is the tangent. Okay, let's see it. There's PK over here. It is a tangent to the circle at K. So it's like K here. Then it says here, the tangent to the circle at K, and then it says chord LS. Okay, chord LS is produced to P. Where is LS? LS is produced to P. LS is produced to P like that. And then here, let's do this. Fantastic. LS is produced to P, and then it says here N and M are points on KP. N and M, where is N and M? N and M are points on KP. Where is KP? Yo, KP. Hey. Oh, M and N are points on KP and SP respectively. Okay, yeah. I mean, like, there's N over here, M down there. Yes, we see it. And then it says here, I am sorry, this is not very clear. MN here is parallel to SK. Are they parallel to each other? Let's see. Well, if they say they're parallel, you know. Can't be fighting with them here. Just like me fighting with my stomach right now, yo. Can't wait to finish so that the boy can go chow. Let's see here. Chord KS chord KS and LN intersect at T. Where is KS? KS and LN intersect at T. Okay. Interesting. Yo, this sketch. Behave, please. For 4 marks, they said give reasons why K4 is equal to NML. Where is NML? NML. Okay, so it's this whole angle here. They said we should prove that this angle is equal to that one. Yup. What a wow, man. I'm going to use some 10 it looks like the 10 chord theorem here, because you see K4 is equal to S1 because of the 10 chord theorem, and these are equal because of corresponding angles. Wow, bro, so easy. Thank goodness. K4 is equal to S1, 10 chord theorem, 10 chord theorem, because you see you have a triangle over here, you see, and then you have the angle here. So remember, this is your chord, and then this is your tangent. So the angle here will be equal to the one opposite the chord there. Then we're going to say S1 is equal to NML. Let's see here. S1 is equal to NML. The reason is corresponding angles. You see, therefore K4 is equal to NML. Easy 4 marks this, because it's like 2 2, you know, 1 2 1 2. I'm like, conclusion is more like a bonus. They're like, no, just give us the conclusion, won't give you any mark for that. But it is what it is. KLMN. Oh, don't worry, you have to say everything, you know, for 4 marks. So it says here, prove that KLMN is a cyclic quad. Where is KLMN? So remember, they will never ask you to prove that something is a cyclic quad if 4 points are already touching the circle. They'll only ask you to prove it if the points are not already touching the circle, you see. So just be careful of that. So what am I trying to do here? Wait, what is it? Wait, what are the sides? KLMN. So there is KLMN. Okay, this one is quite easy, I would like to think. Is it, bruh? Bro, you're busy playing here. KLMN. Okay, if you're gonna prove that something is a cyclic quad, remember, you don't have like many ways to do it. There's just like 3 ways to do it. That's why this question, you can see they're not offering a lot of marks, because you can already see here that an exterior angle over here of this cyclic quad is equal to the opposite interior angle, you see, because you have this long line here, right? Then you have this, then you have that, and then you have that. You see, this angle over here is equal to that angle over there. So that's how you know it's a cyclic quad. K4 is equal to M. It is proven. So K4 is equal to NML. This one was proven, you see. Therefore, KLMN is a cyclic quad. What's the reason? The reason is what is the reason again? The reason is exterior angle of cyclic quad, exterior angle of cyclic quad. Then for 5 marks here, let's see what we must do. 5 marks, they said prove giving reasons that triangle LKN, let's do some colors things here. LKN, let's see where LKN is. Where is L? LKN, okay, so it's this green one here. We should prove for 5 free marks that it is similar to KSM. So proving similarity is not very crazy because they already give you which ones are equal and stuff. So here KSM, where is KSM? KSM, KSM. But let's see, so it's this one here, KS and M. Okay, this is quite interesting. So without bothering yourself too much, just remember that the L here is going to be equal to the K here. The K here is going to be equal to the S there. The N here is going to be equal to the M over there. You just need to show that they are equal with reasons. So let's see what the L, you just choose which 2 pairs are the easiest ones. The third one you just say they're equal because of interior angles of a triangle. So let's see L and the K here. Where's L? So there's L over here for this one. And then for that one there's a K somewhere. Where is K for that one? K for that one is going to be like this tiny angle over there. Yeah, proving that is yeah, that one looks like it's gonna be a mission, eh? So let's move on to another set that looks a bit easier to undo. Let's try the K for that one and the S. So let's see, S for the one triangle is going to be like somewhere here, and then K for the other one is going to be like somewhere there. Yeah, I don't know lie. Hey, I was not answering this question. Dogo. I was not answering it so hard. And now I'm just like, yeah. Oh no, this one we can do. Because of angles on a straight line here, they add up to 180. And then here core interior angles, they add up to 180. So let's do S2 here is going to be equal to LKN. Let's do it. Let's say here S2 is equal to LKN. No, that would be the conclusion. No, but let's firstly state that we know that NML is equal to K4. That is proven. So let's do it. NML is equal to K4. Proven. You see, so these two added together add up to 180, right? So K4 plus LKN is equal to 180. K4 plus LKN is equal to 180. Angles on a straight line. Angles on straight line. Ooh, this one is quite intricate, eh? And then now we can say the same for this one. We have to say they added up to 180 because of co-interior angles. So here NML is equal to S2. NML is equal to no. NML. Which one was this one? Oh yeah. NML is plus S2. NML plus S2. This is equal to 180 because of co-interior angles, you see. Co-interior angles. So you see, remember both of these here are adding up to 180. So now what did I do now? Hey, where was I going with this? Well, which ones are equal? K4 is equal to NML. So you see, these are equal to each other. You see, this one here is equal to this one over here, you see. So you can just put it in a calculation. They're both equal to 180, you see. Therefore, K4 plus N plus this here, this is equal to each other because they're both equal to 180 degrees. And then you have to remember that you can take everything to one side, right? So that this one here can cancel that. So you're going to have here LKN is equal to NML minus K4 plus S2, and these cancel each other out, you know, swing. Therefore LKN is equal to S2. So you see LKN, LKN, there you've proven that it is equal to S2, because you see here we said that you should just match them. You see the K here, prove that it is equal to the S over there. So let's try to prove that the N over here is equal to the M for that one. So let's see, need another color that can like work. I think the pink will do. So N for the one triangle and the M for the other one. So let's see here, N for the one triangle and then the tiny M for the other one. So this one we can just use angles in the same segment, because remember K, N, M and L, we've proven it's a cyclic quad. So you see N here is going to L like that, and then M here is going to K like that. You see, you have to remember that this angle here is equal to this angle, because they are angles in the same segment. You see, because remember this one here is like M3 and then this one here is like N3. They are both subtended by KL, you know. So that's why we're saying angles in the same segment over there. So let us do it. N3 is equal to M3, angles in the same segment. Oh, me maybe write in white. You know, I haven't written in white in so long. Like, oh my goodness. So here N3 is equal to M3. What is the reason? Angles in the same segment. Fantastic. You see, then here you can just conclude by saying, therefore, the last pair here is equal because of interior angles of a triangle. So here you're going to end up by saying, therefore, K2 is equal to L1, interior angles of a triangle. Therefore, K2 is equal to L1, interior angles of a triangle, because you've proven that two pairs are equal, so the third ones automatically have to be equal to each other. Wow, man. Wow, like, dang it, man. So you can then say, therefore, these triangles are similar to each other. Therefore, triangle LKN is similar to triangle KSM. KSM. You're featuring, my guy. KSM is featuring here. Anyways, that's that for 5 marks. Let us move on to the 4-mark question here. It says if LK is equal to 12 marks. Yeah, okay, 12 marks. Okay, thank you, I guess. And 3KN is equal to 4 times. No. Is it equal? Yeah. This idea. LK is 12 and 3KN is equal to 4 times SM. Determine the length of KS. Yo, I don't align these lengths here. They make, without even looking at the shape, I'm going to try and see if we can write out a ratio with these here, because like, why not, you know? Let's see, with these here, right, we know that, since we know that LKM is similar to triangle KSM. You see, without even me looking at the sketch yet, this is what you want to do. You have to remember that questions follow each other, you know. So here, from this, we know that LK over KS is equal to K. Let's see, LK over KS is equal to KM over SM. KM over SM, which is also equal to LM over KM, equal to LM over KM. There you go. So, excuse me. The reason here is just proportionality theorem. So, with all this being said, right? What do we have in the given description? They gave us a value for LK, they gave us something. KN, they gave us, what is KN? No, they didn't give it. We don't have any KN in this expression over here. Or do we? I think we do. I think I just wrote it incorrectly. Yeah, bro, come on, man. It's dude. We're making progress and you're busy ruining everything. Like, why? Eish, have to redo it. Have to redo everything. Eish. But anyways, we're not lazy, so let's see. LK over KS is equal to KN over SM, which is equal to like LN over KM. And then you're gonna have here, you have LK, right? It's 12. KN, you've been given something. SM, you've been given something. So just use this instead, you know. Let's just write this and carry on from there. So here we already know that KN and SM, they've given us this. So it's like 3KN is equal to like 3SM. No, 4SM, bro. It's 4, my bro. Come on now. 4SM. So here you can easily write out a ratio, because firstly you can divide both sides by 3, right? You're gonna have KN is equal to 4 over 3 SM, and then you divide both sides by SM. You're gonna end up with like KN over SM is equal to like 4 over 3. So you have a ratio for this thing here, you see, 4 over 3. They said LK is 12, so you're gonna put a 12 over there, and then there's KS over here. Then you can just work out KS by, you know, doing your gymnastics. It's cross multiply here. You can have 4 KS, and then 12 times 3, it's like 36. Divide by 4 on both sides, or what is 36 divided by 4? Ish, my mathematics it's not working, but I think it's 12. Is it? Yeah, bro. Is it? No. Ish, 12. It can't be 12, my guy. No, man, it's 9. Yeah. It's 9. Yo. Blonding momenting here. Is it 4? Hey, sure, 9. I think it's 9. Yeah, it is 9. Whew, yeah. Mental math is difficult, hey? That's why you must not do it too much. You flop. So it's 9. That's good. Let us move on to the next question here then. For 4 marks again, it says, it is further given that NL is 16, LS is 13, and then KN is 8 units. Determine with reasons the length of LT. So for this question, I just have a hunch that we might have to prove some kind of similarity again, but I'm just dreading it, you know. LN is 16. Where is LN in the triangle? LN is like this side here. This is 16. And then, let me just bring the sketch here, you know, because just scrolling up and down the whole time. Let me just see here. Let me cut this out. Just do this, and let us survey. Survey, Baba. Don't forget to survey your work. Let me paste this thing here. Paste. Hi, man. Over here. So, okay, so now we don't have to scroll too far up, you know. So they said LN is 16, LS is 13. Where is LS? LS. Huh? S. S. Where is S now? Oh, this is 13. Okay, fine. The whole thing here. Excuse me. I don't have flu, but I just feel like there's something in my nose. Dude, calm down. Sorry. LS with 13. KN is 8. Where is KN? KN is 8 over here. Yeah, ne? I told you, I can see it coming. Another theorem proof thing. I'm not keen, but let's see. Then they said here we should get the length of LT. Where is LT? LT is like that one. Yay. So yeah, as I said, now with questions like these, you may have to prove similarity again between two specific triangles. The only thing is, my guy, what did we just prove in the other question here? We got lengths for, I don't align it. This one here is kind of annoying. Like, where is LK and KS? Where is LK and KS? LK and KS. We got that. Yeah, as I'm going through this now, my brain is like, yo, it's bombing out. It's bombing out so hard. But then let me draw the triangles that have these lengths here. So you have KN and KL, you see, like that. And then you know that this is like K, this is like L, this is like N. This is 8, and then they also gave you a length of 16 over here, then they said LS is 13, so you have L over there, you have this line over there, you have S over here, this is like 13. Good. So what else you got? Dust away, I like it, Well, that's all you got, really. I mean, like, the other triangles that we just worked with now, I mean, like, wait, we got what? Let me put the distances of the stuff that we also got here. There's, like, KS over here, ne? There's KS over here. KS, we got it to be, like, 9. And then, what did we also get? Did they give us KL in the previous sentence? But then the other thing is, you may be thinking, can we use length from the previous length? Length from the previous question? I don't see why not, But let's see. Kind of bombing out at this question. Like, it's hard. It's beating. Like, don't let me fool you. This question is beating. I'm just being so extra. LK is like 12. Where's LK? LK is like 12. Okay, fine. There's a 12 over here. So let me just, the ones that we got from the previous question, let me just make it a different color. Just for the vibes, because it's kind of uncommon, this kind of a question. It's like very, very uncommon. Excuse me. But then let me see if there's a way we can prove similarity between these two triangles. KSL. And which one? And KNL. Yo, similarity there. I mean, I don't see it, me. Because, I mean, like, if you look nicely, I mean, like, yeah, they don't look like they're going to be similar at all. They don't look like they're almost similar at all. But for 4 marks, determine the reasons LT. Where is LT, Vele? LT is this length over here. Okay, let's try and see which triangle LT is in. But LT is in, well, there's LKS here, which is the big one. And then I'm talking about LT. Oh, yeah, this LT is a problem, man. Hey, is a problem, this one. But it looks like if we have the whole of 16 here, what did they say is LN is 16? Hey, so like, what if we maybe get NT some way, somehow? Yeah, I mean, like, that's where my thinking is. Maybe getting NT some way, somehow. But hey, NT Leona is untouchable, that one. Let me see. There's T over here. There's L over here. There's like K up there, right? And then let's see. KL, what did we get? KL is like, whoa, there's a common side here. KLS, and then there's like KLN. Okay, this is also 12. And then you have KT. What does we get for KT? KT, we have nothing. And then TL, we also have nothing. This is open, we have nothing. This is open, we also have nothing. Just do this. Just do this here. Okay, I think I should pause and think about it, because, hey, what's the point, eh? Okay, so I guess I've just been, I've been overthinking the whole thing the whole time, man. No, man, no. Just this is what happens when you're doing maths and your mind is somewhere else. I don't know, lie to you. My mind is like, yo, let me tell you where my mind is. My mind is in the future, the happy days. Yeah, happy days are coming, guys. Yeah, I am going to tell you all about it when the time comes. But hey, for now, just gotta sweat it out, sweat it out. Let's see, LN here. and then there's T over here, and then there's like MS. So there's M here and S, right? And then there is L up there. So this is, remember they said that LS is 13. The whole thing here is 13. But then this one whole here is like 16. The issue is they want us to get LT, you know, but we don't have LT. So the issue, I think here we can easily write down LT over LN is equal to like LS over like LM. But then I don't think that's gonna help us much, is it? I don't know. Let's try and see if we can get more information in this sketch. The one piece of information we can get in this sketch, I mean, this should have written it out. I don't think right now it might help us, but the one thing that I can see is in the previous question, where is SM? We had a ratio here. You see, they told us Kn is equal to 4 times Sn, and then we have Kn. Where is Kn? Yes, Kn here is equal to 8, you see. So they told us that in the previous question, 3Kn is 4Sm. 3Kn is equal to 4Sm. That is from the previous question. So Kn, we have it as 8 here. So it's like 3 and 8. This is equal to 4Sm. Divide by 4 on both sides. You're going to have here 3 times 8. I think it's like 24 over 4. This is like Sm, right? So here Sm, you're going to get it to be, let's see, 24 divided by 4, right? That's like 6, yeah. So let's drop in this value of 6 over here, see how that changes the situation. Okay, oh yeah, we can get, yeah, we can definitely get it now, because the whole thing here, oh, let me write what I wrote earlier. Why did I type it out? Let's see here, LT over LM, over LN is equal to LS over LM, you know. Let's say that again, LT over LN is equal to LS over LM. The reason here is proportionality theorem. Proportionality theorem. So now you can put in the values, right? LT you don't have, but then LN, you know, it's like 16. LS is 13. LM is 13 plus the 6 over there. So that's like 19, right? And then you can multiply by 16 on both sides. LT here is like 13 times 16. Whole thing over 19. Grab my calculator quickly. 13 times 16 divided by 19. It is is a fraction. 10.94. Bosso, why do you not have like a nice answer? You know, like a nice answer, but it is what it is. You know, 10.95 actually. 10.95. You get your answer, and that's the rest. That's the whole paper, right? I don't think there's anything else. There's any other question here. So this paper, I think just the Euclidean section, especially this question and that 10 point something. Yeah, I don't know that these ones. This is the 10.4 and this one are the ones that are just crazy. But anyways, that's that for this paper. Don't forget to share, like, and subscribe. Don't forget that this is the course platform. You can go and sign yourself up. Remember, if you're in grade 11 and you're watching, and you know someone in grade 11, right? And this is like 2021 or something. Remember, you have to hit them up and tell them that they must sign up now. Otherwise, next year is gonna be more and stuff. But it is what it is, you know. That's all I got to say. That's all I got to say. I will catch you in the next video. If you need to ask anything, you can just always DM me on IG. Remember, if you're gonna DM with questions, and just at least have the memo, you know, and have the memo. You have gone through the memo, and maybe the memo is not making sense. Then you can ask, you know, because it's not good to practice with stuff that don't have a memo. Anyways, that's that from my side. Ciao.